I do that? Hey, welcome to the party. Okay.
I've been in this room.
Really? You've never been in 102? Really? All right. Well, okay, so for those of you who are watching the stream, I just reminded everybody to fill out their CIOS and TAOS. Right now, the response rate is about 39%. That needs to be 80 for you guys to get a little bit of extra credit on your final averages, so make sure you fill that out.
Do it.
Yeah, boy.
It's a tall stool.
Okay, so as I said, this is going to be a more question-based review session because unfortunately we can't reteach the entire class in 3 to 4 hours. So we need to know what you guys want to know about. I did send out that extra XML question. I'd say those two are probably, you know, the reasonable types of questions that we could ask, both the one we gave you in recitation and the one I sent out on XML on there, as well as being familiar with some definitions about XML. That would be a good thing to know. Other than that, all of the other stuff we've gone over in the class. All the things that have been covered on Exam 1 and Exam 2. Fair game. It's comprehensive. Yes?
So is the turtle stuff going to be on?
No. There will be no turtles on this exam. Yes?
So do you have like a specific plan of what you're going to start out with for this review session right now?
I was thinking of mainly going kind of chronologically through the class, so we start with some of the basic stuff and then move on to the later topics in the class. Yes, do you have a question?
Yeah, I just had some topics in the beginning of the course I would like to be covered, but if you want to go chronologically, that's fine.
All right, let me first close Google Talk. Okay. All right, so what is it you'd like to cover?
I would like to review like maybe 2 or 3 code writing problems that deal with strings and lists and the import string method, which was a problem seen on exam 2 for this summer, and different list functions such as the sum of the list, and if possible, like if you could review all those helpful functions that'll help us write code.
Some math, man. I don't think I've ever seen it.
Average?
Is there an average? There's a sort and a reverse.
Ah, yes, sort.
In the reverse, that's useful.
All right.
List dot average.
Actually, no, I think there is like an AVG parentheses something.
What would it give you on a list of like strings?
An exception.
No, it only works for a list of numbers.
What's up?
Can we
Nope.
also go over the test 1 and test 2 recursion?
Test 1 and test 2 recursion problems, all right?
Stop smiling, James.
You don't like recursion? It's not fun? There are select few problems that recursion is actually better to use than looping and things
If you
like
were going to try to traverse an entire XML tree and print out everything in the XML tree, trying to do that with iteration is almost impossible.
Give me an example of that.
We're not going to ask you to do that. That's a CS 1332 problem. Okay. Anything else in basic Python land? Iteration, conditionals, anything like that?
Yeah.
Mhm.
Nested for loops, please.
Nested for loops. When would we use them? All right.
Okay, so no turtle stuff then.
No turtle
No
stuff.
turtles.
But next semester.
Oh,
Oh.
God.
Mm. Yes.
I hate this.
All right. So let's see. Where do we want to start? I guess we'll start at the top. Code
I'll
writing
s-
with strings and
I'll start
lists.
with strings and lists.
All right. Strings and lists.
String and list questions.
Oh, can we do tuples and dictionaries too?
Absolutely. That was not well thought out. Oops.
Nah, it's fine. They can totally see that. Taking a string. and I already did that string function.
I bet they don't remember it.
What about
I'll erase the
taking
S.
a string and creating two like substrings with capital letters and one lowercase in the other?
You lead. Not following.
That's your regular expressions.
Regular expressions. Oh yeah, that's later on though. So we'll go over those later.
I can't use that mouse, can I? Okay. So, code writing with strings. You want me to just start with the
Yeah, just
example?
go ahead and give them the problem. and
All
we'll
right,
let 'em
so
work on it for a minute.
what we're going to do is we're going to take in or write a method that takes in a string. So we have a parameter of a string. Of course, returning it would require you to return a list.
Okay.
You're going to take that string and you're going to make two strings with it. You're going to put all the uppercase in one string, and in the other string, you're going to put all lowercase. So, in our function, if you were given hello world, the uppercase string would have HW. The lowercase string would have ELLOORLD. Does this make sense?
Questions?
What the
Space there.
you don't have to worry about the space. Now, are we going to give them a chance to work on it?
Yeah, well, actually, we could have a group solve on this. All right, so what's the first thing you might want to do when looking at this problem? Yes.
Import string, and then import the uppercase and the lowercase string.
All right.
All right.
And create an empty string.
Definition. Split string. Taking a parameter of old string. Alright, so import string.
Now notice here that James is actually importing inside the function here. This isn't something you see a lot of in this class, but it is perfectly legal. So that would be essentially the same as if we imported inside or outside the function definition.
You can
They're
also
both the
put the
same.
import here. Import string.
Question? Yes.
If you were using two different functions, you will have to, if you were using the import string, you will have to import the string again in the other function. Right?
Yes, that's
As
correct.
If you were to import the string like all the way from the beginning before writing the definition, it will be much better because it will take care of all of that.
Yes.
Right.
Right?
Yes.
If we're writing a file, most likely you would put it at the top so that everyone could see it.
Yes.
Quick question, is this, I know you're recording this, are we gonna be able to see this like after you're done, you can post it?
Hopefully.
Yes, I can make a
I remember
PDF.
last time there was, like, the issue
Right.
where-
The stuff that we write down, I can save as a PDF and post under resources.
Okay.
So it doesn't have all of our notes in it, but it'll have all of the code that we write and all of that stuff. in it.
And hopefully, this should be posted.
Yeah, that's why I keep this little bar up at the bottom on, so I can make sure that it doesn't die. Yes.
So you're saying even if we had another function, like since we imported the string, it'll still work with it? If we have another function?
So-
What we mean is
Let's go
that
to
with
idle.
this, right, with that particular function, what's happening there is if we import inside of the function, that import is only valid inside of that function. So it's like declaring a variable inside of a function. Once that function is finished, that import goes away. We can't use it anymore.
So there's no value really inside the function, is there?
There is if you're only ever going to use that import inside of that function.
But even if you only use it inside the one you imported out, it doesn't affect the other function, does it? Like if you put import string above the split string function, it's not going to affect the other function even if you never use the string.
For the most part, yes. There are circumstances where it will have some unforeseen consequences because of the way Python does imports. If we had a function named the same thing as one of the functions in the module we were
Where's your-
importing, it would basically trash the function we wrote. Or no, it would trash the function that we were trying to call. But that's way too complicated and not ever going to show up on an exam. So you can do it either way, and it's
So
perfectly
where
valid.
do you want this saved at?
Summer 2011 materials.
This.
Yeah, that folder.
Okay.
Gasp. Exam questions. I've been a bad TA. I haven't written my questions yet.
So if we call split string,
Just start showing us stuff in that file.
I haven't written them yet. Sorry. There's nothing to show.
I don't believe you at all. Whatsoever.
is
James
it
can tell you,
ASCII
there's no email
underscore
on the list.
Uster case?
Um,
Is that what it is? Just wanted to make a point.
Might need to close the-
What's the other method they use without using import string?
you can use up.upper and .lower without importing string to upper and lower case particular portions of a string, but isn't it ASCII underscore uppercase?
Isn't it
What's good
STR
about
dot lower string?
I'll get it at some point.
Hmm?
Is it STR dot lower, STR dot upper?
The dot upper and dot lower methods are something you call on an existing string. So for example, let's say we had x equals the string hello world. If we wanted to uppercase everything in that string, we would say x dot upper parentheses parentheses, and it would return to us that string in all uppercase letters.
There we go. So the dot ASCII underscore uppercase just gives you a string with all the uppercase letters in it. And if we were to do this, it would fail. So we imported string in the first function and we printed out string dot ASCII underscore uppercase. It worked fine, but when we tried to do it in the second function, it didn't work.
What does importing string do?
So string is a module right there, and it has some additional functionalities on top of the base operations for strings. So one of them is it has this list of all uppercase and all lowercase ASCII characters, which is useful to you for this problem. So James is going to, we haven't imported it yet.
Yeah.
It's a good day for James Moore.
It is a great day. There.
Okay, so this is all of the stuff that it has in it. Translation tables. Scroll up.
Anything useful? Cap words?
Words. There's a bunch of stuff in here that I've never really seen.
Whoa.
Yeah.
Hex digits.
So there's some white space. Whether it's printables, there's just a whole bunch of stuff in here that you might use if you're doing certain string manipulation. But really, we're going to restrict what we would ask you to know maybe to upper and lower case.
Now, one key thing, you don't have to use ASCII underscore uppercase. You can just make a one string with all the uppercase letters. And it'll work exactly the same.
Yeah.
It just takes a lot longer to write down. So EFG.
And you don't have to write it all out.
I was going to show that it was equal to
You're not assigning it to any. Oh, never mind. You don't have to.
S T U V W X Y Z. S. String. You're so right. Underscore upper.
String dot ASCII. Nope, typo.
Oh my god. Your keyboard. Make it. How do you spell ASCII?
ASCII.
It's right in front of my face.
No.
I'm done. Okay. Point I was trying to make is the string that is the exact same thing. It just takes a little longer, right?
So for this particular problem, if you forget this whole import string stuff, that's okay. You can make your own version of this if you need to. It just might take you a little bit longer, and there's a potential for error. So, like you saw James,
Fail several times.
yeah, forget some characters earlier. So, back to the problem. All right, so we've imported string, and we've gotten our function definition. Now, for the most part, in an exam question, we would give you the function name and all of that other stuff because we want you to be specific, and we also want to give you points for writing the correct function definition.
Always do that, please.
Yes.
Write a function definition.
Yes, if nothing else, get the function definition right.
And almost every question that's code writing, we'll give you points for it.
Mm-hmm. Oh yeah, we have a brand new stamp. It's the seal of awesomeness. So you want to get one of those. It's good. You might never see it. What?
Can you email us and let us know for that seal of awesomeness?
Sure.
Do we get a point for that?
No. It means you got it right.
It means you got completely right.
Okay, so now that we've imported string, we have access to string.ASCII underscore uppercase and ASCII underscore lowercase. Now, how is that going to be helpful for us?
Compare your parameter to one of those. And like, the string has that. Using it.
In general, yeah. Yes.
Could you do a loop that pulls out each individual letter from the initial string and do an if statement to see if it finds it in either the upper or lowercase values?
Mm-hmm. Exactly.
Yes.
And that's exactly what we want to do. Now, the order in which we're looping in this particular case is very important. We want to be looping through old string. We don't want to be looping through ASCII underscore upper and ASCII underscore lower, because we need to be considering each individual character in the parameter string, not each individual letter in the alphabet. Make sense? Okay. So, before we can start doing that looping, though, what do we have to do?
We make empty strings, I guess, because we're coming up with those outputs.
Exactly. We have to have somewhere to
Exactly.
save the results.
For letters.
All right. Now that we've got that, what is the loop we're going to write here? Yes.
G for loop
Mm-hmm.
or X in old string.
Yep. That'll work.
I'm going to change the variable for char.
By the way, using good variable names really helps. Helps you and it helps us.
Isn't char a built-in function now?
No.
CHR.
Yeah, CHR is the built-in function. CHAR is not.
This is not Java.
All right. So now, what does char represent?
Each individual character.
Each individual character. Right, so each iteration of the loop, we keep going one character forward in old string. So now what will we write?
You do like an if statement.
Mm-hmm. So what would our if statement say?
Well, I would have done it like this. I would have done it like partially set equal or something. And then, like, if a character is in, like, so do all the uppercase characters and set that equal to upper, and then so all lowercase characters set that equal to lower, and then say for character in old string if if it's in upper, then append it to the list,
Mm-hmm.
and I do that twice.
That's actually what we're going to be doing here, except that we already have our list of acceptable characters made for us. The Python developers already put it together. It's called ASCII underscore uppercase and ASCII underscore lowercase. So we just have to check and see if it's in one of those two strings.
You don't have to assign it to a special variable.
Question?
You can just use it.
Because what I was thinking we should have assigned the ASCII underscore uppercase and lowercase to specific variables. So
Mhm.
you could say if char in that variable.
It's completely acceptable. Okay, so you can have, upper equals string dot ASCII underscore uppercase. I'm gonna run out of room. Case. And then you can have the other one. That's perfectly valid.
Mm-hmm. That's completely acceptable. But,
Do the is without the
hmm?
Can't you do the if
Yes,
Yes,
you can.
Mm-hmm. So basically, everywhere that you're going to see us use upper and lower, you're going to substitute in string.ascii underscore uppercase and string.ascii, string.ascii underscore lowercase. That's the difference. So if char in upper,
That's the same thing as saying if char in ASCII, string.ASCII underscore uppercase.
so everybody knows what in is doing here, right? Yes.
If we were to add something like not in, would we have not in the front or like right before in?
If you were to add not, you could add it right before the word in. So it would be if char not in upper.
I'd use the exclamation point. Do they know that?
No, I don't think you can use the bang there.
You can't put it in quote. It returns a true or false statement. Bang it. Should work.
Yeah. I think we just taught them not.
Okay.
Yeah.
You can use double equals here too, right? If
No.
char equals-
No. The
Remember
reason-
that character is a single letter. So it could be like capital A or capital B. Whereas upper is an entire list of all the capital letters.
Well, you could do double equal if you did like a whole other function.
Yes. If we were to embed another for loop inside of this and have it loop through upper or lower,
And
then
it's equal to the index in upper, then it's
yes.
obviously capital letter.
Right.
That would be valid too. I mean, you can write that down. It's just a lot longer lines of code.
Yes.
Does the find function work here? If you were to do, obviously it's easy to do it this way, but if you see like the find char equals upper, to find where it is, and if that ends up being the case, so it ends up doing a true false statement, true or false based on whether it finds char.
Yes, you could do that too. You could say whether if you do a find and then the index that it returns to you is greater than,
0.
yeah, or that might be index
Actually,
of. That's probably
I
index
thought
of.
if you put that whole thing in parentheses, it turns it into a true false statement, because it's the if else.
I don't remember off the top of my head. I'd have to look it up. But yes, you can do it with that. I just don't remember the exact syntax to do it with that.
You could do it with the index of though.
Yeah, you can do it with index of too, and check and see whether the index of
Is
is
greater
greater
than
than, or is equal to, or greater than 0, and that would be valid. All right, so but for right here, we're going to do it the simple way and just do it for char in upper. So yes,
So if char in upper, we would do lower letters dot append.
Upper letters. Well, you can't append.
You can't
to
append.
the
No, you
list.
gotta
It's a
just
list.
add it.
right.
Yeah.
Aha.
Oh, yeah.
Yes, pitfall. We cannot append to a string. We have to concatenate. So in this particular case, for char in upper, the only way that the stuff inside of that particular if statement is going to execute is if the character that we have is actually in upper, which is our uppercase string. Now, if that is in fact true, then that means that we want to concatenate that particular letter to upper letters, not lower letters.
To make sure I
Yeah. All right, so now we're going to do our concatenation. Remember that strings are immutable. We cannot change them after they're declared, so therefore whenever we do any operation that's going to change a string, we have to do an assignment back. So like upper letters equals upper letters dot, or upper letters plus whatever you want to put on the end of it.
Alternatively, comment this line out. You can also say upper letters plus equals char.
What does that mean?
So plus equals is shorthand for the line that's written above it.
They do the exact same thing. And these shorthands, while you're writing it on your computer, aren't written. Sometimes they're useful, but on the test, if you remember them, they're very useful to save time with.
All right, so we have the uppercase condition. Now what else are we going to write down here? We have our other condition. Mm-hmm. Char in lower, yes. Why would we not want to use an else here?
Because it could be like a number.
The white spaces.
Bingo. Any other character that is not an uppercase character, which could be a lot of anything, really, would also trigger that else. So if we had numbers or spaces or, I don't know, Chinese glyphs, that would work too.
To look at his
Wouldn't we put an
approval.
else statement for this one?
In this particular case, no, we don't want an else, because we want it to discard any character that's not a letter.
Let's look at string
Well, I'm
dot
saying, like,
printable.
after the else statement, because we don't know what the string has to.
Well, that's not what the function's asking. It's just asking for one string with all the other cases, one string with all the other cases.
So if there was numbers in the string, it just wouldn't fit in.
Right. So basically, any of these numbers right here are not going to be in either of our strings that we return.
And none of those symbol
Yeah,
things.
anything after Z over there is not going to be in it either. All right. All right, so we have elif char in lower. We're going to do basically the same thing we did in our if condition here, except we're going to make sure that we append it to lower letters this time. All right, so is there anything else that we need to do inside the for loop, or are we done with the for loop? Okay, we are done with the for loop. So, when this for loop is finished executing, what is true?
The letters of all these characters.
Yes. So now all we need to do is construct our list that we're going to return and actually return it.
So we should create an empty list and then append the two things to the list.
That's one way to do it. Yes.
Couldn't you just do like final equals and then in the brackets, upper letters, lower letters?
Yes.
Pattern it that way.
That would be perfectly valid too. Hmm?
What if you didn't have a variable named final and you just said return and you have a list of
Also valid.
Completely valid. Yes. So I think you're seeing there's lots of different ways that you can go about doing this. So that's the beauty of code writing problems, is you don't have to know exactly one way to do something. So
I did that backwards. Awesome. It's the same thing. You can do it.
all right. So that's that problem solved. Now, notice that we did not try and return twice here. We did not try and return upper letters and then return lower letters, and we also didn't put anything below that return there. Seriously, if you put something below a return, I will see you one day, next semester, or after that. Sometime I will find you, and I will find your exam, and I will hit you over the head with it.
Also, we didn't put a return statement in the for loop. Also bad.
Yeah.
Can you say that one more time?
You don't put a return. We did not put a return statement in the for loop. If you put it in the loop's only going to run once. And it's going
That
to hit
was-
the return and stop.
That was an exam question on exam 1 when we asked you what the value of B was, if I remember correctly. In one of those problems, it was multiple choice. The return statement was inside the for loop, so you had to know that it was going to immediately return inside that for loop.
That's only for return, right? For print, it always go to.
Yes, that's correct.
Unless you're trying to use this determining, in which case you would use it.
Right.
There are certain cases where you
Like
could.
wild true ones.
Right.
Yeah, like in raw truth, that would be acceptable.
Right. For the most part, we like to say that using return inside of loops is bad, but if you know that if there's some condition you're checking for and you get to that condition and you know you're not going to have to do anything else inside the function, you can use return. That's valid. All right. What else do we have to go over?
I can't think of another.
All right. So we.
I have a quick question.
Mhm.
Yes.
Yes.
Can you just walk through how you would do it if you want to replace an upper letter with a lower letter? Because I think that was on exam 2 and I just forgot how to do it.
Okay. So with this one, in order to replace characters, we can't really replace characters in a string because that falls victim to the rule that strings are immutable and we can't change a string after we create it. So what we're going to have to do is we're going to have to actually create a brand new string. So we would do something like, if our original string is called orig string, if this is our original string right here, we're going to have to say something like new string is equal to an empty string. And then we will loop through. So for each character in the original string. And then what character were we trying to replace? Are we trying to say, uppers instead of lowers, or?
Both. If it's upper, change it to lower.
Okay, so swap it. Okay. So in this case, we're going to import string again. And then I'm going to say, okay, if the character is in string.ascii.
Aha.
Yes. Okay, I goofed. ASCII underscore uppercase. Then we're going to append. So we're going to say new string. Curses. New string plus equals the character dot. See, this is an uppercase, so we need to go lowercase. And then we have another condition. And that other condition is going to be if the character is in string dot ASCII underscore lowercase. Then we're going to concatenate char dot upper. Now, in this particular problem, I don't remember off the top of my head, but there is the potential that we could give you characters that you don't need to upper or lowercase. Now, we could have just used an else here, because if you try and upper anything that doesn't have an upper or lowercase variant, it just leaves it alone. But I didn't do that. I said an elif, so I'm just going to put an else here. And that else is going to be new str plus equals char. And so now, by the time this for loop finishes executing, we are left with new string being all inverted case.
Digits or digits, right? String dot digits.
I think so. Question?
There was one where it was, whatever the string was, it wanted it to alternate.
That's
Upper, lower.
right.
That's
That's what
this.
this does.
That'll do
That should alternate upper and lowercase letters.
what's on the board right now.
Yes.
No, I thought that only changes every uppercase to lowercase, every lowercase to uppercase.
Yes, it is.
I'm saying if it says like hello world, it doesn't matter what they are.
Oh,
The first
okay.
letter's gonna be lowercase, the second letter uppercase. the
Okay.
third letter, like regardless of what they are.
Okay. All right. That one. Okay.
That was on test.
So you guys want to see that one? All right. All right, so we're going to write our function,
Modulus.
diff.
Can we do it without importing the string?
Actually,
you shouldn't
yeah.
need to on
Yeah,
this
you
one.
shouldn't need to import string on this one.
Because this was done based on what place it's in, and not if it's upper or lower case, you shouldn't need to import string.
Yeah, you did. All right. Let's see if I can do this without screwing it up. All right. Too much.
You gonna range it or you gonna make it count?
I'm going to arrange it. Okay. So we have our original string. Right now I'm going to make our string that we're going to put all of those characters into. So I'm going to say new str is equal to an empty string. Now we're ready to start going through our loop. Now for this particular loop, because we have something that is contingent upon which place in the string a particular letter is, I'm going to use a range. So I'm going to say for index in range, and I want to consider all characters.
We didn't think of length.
Hmm?
We didn't think of length up at the top.
Yeah. To the length of the original string. Original string. Now we're ready to go. So, note here, what is index?
Numbers, like position.
Yes, it is a position. It's not the actual character. It's very important to remember.
Anytime we use a range in the for loop, it's going to be a number, never a value.
So for this particular one, what I'm going to do now is I'm going to say, all right, we're going to use modulo here. So every even numbered character is going to be uppercase, and every odd numbered character is going to be lowercase. So that means it's going to start upper, go lower, upper, lower, until we get to the end of the string. Yes?
Is there a reason you're doing range from 0 to 1?
Yes, because indices start at 0, always.
But doesn't the range function automatically start off at 0?
Yes.
You could have
So,
just said length of
right, I could have
original
just
string.
done this.
That's valid.
Okay. Sorry, that's what I was wondering. I just know.
Yeah, it's exactly the same thing as what I wrote.
That's what I thought.
All right.
If you're ever confused on what the default is, you can always just put 1.
Yes.
Very rarely will that hurt you.
All right, so we're going to say if index modulo 2 is equal to 0. Okay, so that means that we have an even number. So it's 0, 2, 4, 6, blah, 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 which means that we need to uppercase. So we're going to say new string, except I wrote out new string, plus equals the orig string at index dot upper. Yes. And it does say plus equal. That's a plus sign. That's
Oh, you're
that's
right,
a
I
plus sign.
My bad.
Okay. Okay, so what I did there is I said new string is equal to new string plus the original string at position index dot upper. So here's what that did. It did a lot of stuff on one line. The first thing that happens on this line is it's going to do this right here. And so it's going to pull out the character at position index. And so now we're left with a string that's one character right there. And then dot upper is called on that string of one character. So it's going to uppercase that one character. And then finally, the last thing that happens is this assignment operation where it says new string plus that uppercased character. And then we put that back in a new string.
Yes.
Could you explain the modulo?
So the modulus is used for finding the remainder of something. Okay? So when you do index modulus 2, you take whatever the index number is, divide it by 2. Yeah, there you go.
right? So this harkens back to the days in elementary school when we first learned long division. And we tried to divide a number into something that didn't go evenly. So 3 into 10 goes 3 times, but we have a remainder of 1, right? The modulo operator is a shortcut for saying, tell me what the remainder is in that division problem. So for example, if I said 10 modulo 3, this is going to be equal to 1. Because that says, okay, tell me what 10 divided by 3 is, and then give me the remainder of that division.
So saying whatever the index is divided by 2, the index for the remainder will be 0. So it's going to be even.
Correct. Should the first one be lower?
It depends on which one the problem tells
Right.
you to start with.
I'm not using that exact problem. I said the first character needs to be upper and the second character needs to be lower. I wasn't going off the exact exam problem. Yes?
I'm kind of having trouble understanding the syntax. New string is equal to new string plus original string index. Now, what is the dot upper? The dot upper is in the characters of the uppercase. That's the index.
So here's what this is saying.
Split it up into multiple lines.
Yes, I'll split this up into multiple lines here. All right, so the first thing that I did is this underlined part. That's the first thing that gets executed here. And so that's like saying char is equal to ridge string at index. Okay, so what that did was we pulled out one character from the string, right? And that one character is the character that we need to upper or lowercase. In this case, it needs to be uppercased. And so then, on the next line, I'm going to say char equals char dot upper. All right? So I've uppercased the character and done a reassignment. So now the character is uppercase.
Okay.
And then the last thing I'm going to do is I'm going to put that into new string. So I'm going to say new str equals new str plus char. Okay, so this line right here, why did that erase that? All right, that line right there does the same thing as these 3 lines below it. So the first thing that happens is we're going to get the character that we need to uppercase right here, this underlined part. The second thing that's going to happen is it's going to uppercase it. And the third thing that's going to happen is we're going to put it into new string.
If you're uncomfortable with this one-line syntax, don't try to memorize it.
Just write it out.
out all 3 steps.
Yes.
If you don't remember how to use the other one. There's nothing wrong with doing that. It's not like you get points off. Whoa.
Yes.
Yeah.
That plus sign is like the append function. Since that plus sign is adding each letter to the new string, it's just like the append function.
Pretty much.
In case of the append function is added to a list.
Right. The only difference is that it's going to return a new string when you do that. It's not actually going to change the string you're plussing it to.
So it's not like it's substituting each letter, it's adding each letter to the.
Yes, and giving you a new string each
If you had
time.
not done the assignment, so if you said new string plus char, that's not going to change new string. But other than that, it works the exact same way as it did.
All right. So we have our else condition that we want to lower. So the else condition is going to be triggered when we don't have an even numbered index.
Alternatively, you could have said elif index modulus 2 equals 1. That would have been fine too.
Yep. All right. So, yes.
Assuming that when you're beginning a string that has only letters, or only characters.
Well, this particular string, the else condition, if we try and upper or lower a letter or a string that has characters in it that don't have an upper or a lowercase variant, let's say digits, for example, it's just going to leave them alone.
You
So-
could say elif and then have an else at the bottom that didn't do anything to the character.
That's what we did for the previous problem, actually. Yes.
What do you mean it's gonna leave it alone? So like if I was to do x dot upper and x was equal to 0, it's just
It's just going to give you a 0.
really?
Go to
Mhm.
Python.
I didn't. I think there's an error. Yeah, it shows me an error. Oh, it's a string.
Mhm.
Oh, yeah.
All right.
The string is here.
I would say go on the list.
Yep. All right, and so now by the time this for loop finishes executing new string, we're just going to return that thing, return new str, y, wow,
Ooh, look, it looks.
squished. All right, and then we return new string, and that's the end of the problem. All right, lists. Yay, lists.
Are there any more useful string functions to know for this file?
That's pretty much it.
For the import string is pretty much it. There's also string.digits that might be useful.
Okay, what the string dot digits do? Gives
It's
us-
very similar to the ASCII underscore uppercase or lowercase, except that it gives you a string of numbers. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So if you're looking for something that's a digit in your string, you could use string.digits.
Okay. Lists.
List. Did we want?
Recording is recording your voices too, right?
Yeah, I hope. Make sure it's still running. That's not what I wanted. Control bar. Okay. That's good. For lists, did you? All right, so there's a couple. Yeah. Oh, I'm sorry. Was not looking.
Can we have done something like instead of doing the modulo function with the index, if it was a while loop, if we said like while index is less than the length of original string, and then like done something where we do index plus 1 and then just do those as upper and then just a regular index as lower.
What do you mean those indexes upper and
As
right?
in, like instead of using for loop in the beginning,
Mm-hmm.
we should do while index is less than the length of original string.
Okay.
And then we set the index as 0 to begin with.
Okay.
And then we make like another index where like it's used
Two
for
index?
only, yeah, 2 indexes, one for upper and one for lower. Could we have done that?
The issue with doing that is you can't index into strings and assign things. So if you do new string at index equals something, this is bad. You can't do that.
The reason you can't do that is because strings are immutable. You can't do anything that is going to change a string in any way, shape, or form. It will not do it.
So you would
Yes.
How about use slicing?
Slicing gets a portion of an already existing string and gives it back to you. So you can't use slicing to change a string.
what you could do. Okay. For slicing, if you sliced out every other character starting at 0 and then sliced out every other character
Okay.
starting at 1, you could uppercase them, lowercase them, and then put them back together. That's valid.
You'd have to weave them together.
But it's a lot more complicated than doing
I'm
this.
saying like while index is less than the length of the thing, right? And then while index is less than the length of original string, and have 2 counters, index and also this thing for uppercase only stuff. So like
Is this
let's say
insert?
upper index would equal
Is this
index
not-
plus 1, and that way we can just index that out for the uppercase.
I'm not quite sure that would work.
So you
Yes.
wanted a while loop?
Please talk about there are some built-in pointers in Python that when you try to change something like in a list and you set it equals to like some other variable, when you try to print that variable, it will return now.
Okay, yes.
Dot append.
Yeah, dot append is the main offender in terms of that.
What were we just doing on Python?
What?
What were we just doing on Python?
Something that I don't think would work.
Yeah.
I was gonna-
Reverse. Append and reverse. If you do like
So list dot
Yes.
append, list dot.
reverse.
What?
This is
Okay.
what happens when you punch keys accidentally.
List dot reverse.
List dot what?
I was just saying I forgot what list.sort was, but I remember.
Is there any other ones? I can't think of any other ones off the top of my head,
No, none that will return none.
but these return none.
Right. So those three are the ones that return none. So you don't ever want to see these three functions and then an equal sign over to the left. That's bad.
This is the worst one. Never do this.
No, that will get you a look of disapproval. That's another one of those things that I will find you after this finaling.
Bad.
Did you get an error or like?
No, it will not give you an error. What it will do is it will take the list, append whatever you told it to. So you've got your new list with your new item in it. Then that append function returns none. So the next thing Python sees is list equals none. So you've basically just said, hey, I added something to the list. Now I don't have access to it anymore.
Yes.
And the print function returns none as well, right?
Yes.
Correct. Anything equals print is also bad and will get you a whacking.
So that door was locked.
That door's locked?
Yeah.
Really?
Is there another marker I can go
I'll
blade
put
at
a
the door?
trash can in it.
Trash can.
So if you do return print, something will return.
It's always returning none. It doesn't matter what you print. The other main functions for lists are max of a list, min.
Does max return? Max returns the value that's max, or the index of the value that's max?
Returns the
Value.
max value.
The max value.
Value.
Oh,
Max
wrong.
value of min.
How about if you do print chart? That would work.
One second.
So, hang on. We need to go over return and then inside the return, print, and then we need to do print and then return inside the print.
Return print.
Yeah, and print return.
Yeah.
All right, so those three functions at the bottom right there, they only work for lists that have numbers in them. More appropriately, the list can only be numbers. If it has anything that is not a number in it, that stuff will throw a big red exception because it's like max of strings. What are you talking about? I don't know how to max a string. You're crazy.
All right. So, do you need that?
No, we can talk about what happens just on.
Okay.
Yeah. All right. So return and print. All right. So we know from the beginning of the semester that doing this is bad, unless you just wanted to return none, in which case, go for it. But I can't ever think you'd ever want to do that. All right. Now, I've also seen a variation of that, which is this. All right, that right there. What happens when you do that second thing right there?
It just prints return var as a string.
No.
It's gonna return var and stop.
Exactly. It's going to return var, and then it's not ever going to print it. That statement's never going to run. It's just going to return it, and that's it. So it's as if you just had that right there. So don't try and stack up returns and prints on one line. Just if you need to print a variable or something,
Do
print
it
it before the
first.
return. Don't ever put it after the return.
So the return print var produces an error.
No,
No.
it's not an error. This right here will give you
First, you'll see whatever var is on the screen because it did the print function. Then, whatever function is returning returns none.
Okay.
because
And then,
the print function returns none.
and then this one print return var just returns var, stores the value, but doesn't print anything.
Exactly. Remember
Yes.
that when you hit return, it stops, no matter what's after it.
Right. All right. All right, we got the list functions. That's done. All right.
Do we need to tell them sorted? Would that be useful?
Nah, not really. You can use a list.sort. They can sort in place or make a copy before they sort. That's cool. All right. So, recursion.
One thing, the list.sort and list.reverse, they change the actual list.
And they return a list.
They don't return anything.
Nope. These three
all
guys right
return
here.
none.
Oh yeah, that's right.
So they will actually change that list, whatever the variable is called, it will change that list. If you want an unchanged version, you're going to have to make a copy of it. I know I've seen that in some of our exam instructions to not change the list.
So if you ever have to do something to a list, let's say it asks you to return a list where every element in the list is multiplied by 2 or something like that, and we tell you don't modify the original list, you need to make a copy first. Make a copy first. If you don't make a copy and you just do, list at index is equal to list at index times 2, that will modify the original list because of the rules of aliasing, and you will get burned because you will have modified the original list. That would be a very sad day. Yes?
Would you guys be able to give us like the rules of aliasing 101 for like lists versus immutable objects?
Okay. The thing you need to remember is immutable objects are always going to give you a copy. You can't ever modify the immutable objects, so if you're ever appending anything to them, or you're ever creating a new one, or whatever, you're never modifying the original. It's impossible to modify the original.
I mean, is there like a general thing that we could write down?
Oh, well, so the basically thing you need to know is aliasing. Basically, if you modify one alias, you modify the other. An alias modifies both.
That's only for immutable stuff.
No, it's only for mutable stuff.
That's for immutable.
Right.
This is mutable.
So
Yeah, it's a whole concept.
immutable objects, if we were to say, x and y was strings, okay? Strings are immutable. If we said, x is equal to all the uppercase characters, and then y is equal to x,
Do you have to write these down?
yeah,
Yeah, here you go.
yeah.
Let's put mutable there. Well, I won't actually.
All right. So let's say we had, x is equal to ABC, all right? And then we had the line y is equal to x, all right? If we say something like x is equal to
Use the is
xyz,
keyword.
I just want to see if they know what's going to happen here. All right, if we add x is equal to xyz, what is y? Yes, exactly. That right there is essentially pointing to the same thing. And then when we change what x points to, it doesn't modify y. Okay, that's basic variable pointer magic. Okay.
It goes like in order, right?
Hmm?
Didn't it go like in order?
What do you mean?
Like, well, I don't guess you can change a string.
Because the string is immutable, that's why they're pointing to different things.
Yes.
Okay.
Now,
So y was ABC or y was x?
y is ABC, and it did not change when we added that second line.
Third line.
Third line, yes, third line.
But then, all right. So what if you? Oh wait. Well, you can't change the string. Hey, never mind.
There you go. Other questions?
That's only if you were like assigning x and new values after the y equals to x, right? Because if you have like x equals to ABC and then x equals to x, y, and z, then y would be x, y, and z, right?
No, that will never happen. So basically, the only time that we can get y to change when we change x is if we do something to a mutable data structure and we change that data structure. So What are our mutable data structures? Lists. All right, lists and dictionaries. Yeah, that's it. All right. Now, those are our mutable data types. The only way that we can manage to change one variable without actually touching it is if we are messing with one of these two data structures. Everything else, you can't magically change variables from other variables. It's impossible. So I'll show you what happens when we do this with lists. Let's say we have x is equal to me,
Hitting buttons.
yeah, fat arming my keyboard.
Should be able to like
1, 2,
hit a
3.
button on the screen to turn off
Keyboard, yeah, that would be cool. That's called flipping the screen around this way and putting it down. All right, so we have x is equal to 1, 2, 3. We now have a list. All right, if I were to do something like y is equal to x, are x and y both the same list? Do they point to the same list in memory?
Yes.
Yes, they do.
They're alias.
They are aliases. That's exactly right. So these two right now,
And if they are aliases, that means you can modify them.
mm-hmm.
So if you modify x, it changes y.
And in
if
the
you-
end, you say print x, print y. They're gonna be the same.
They're going to be the same.
Yes.
No matter what
So-
you do to them.
The difference between like an alias and a copy is the type of data that it is, right? Like whether it's mutable.
Not quite. So
'Cause like up there, that was like copy up there, right?
No, it's an alias, but.
Both of them are aliases?
No. Well, technically, they probably
A
are
way to get a copy
aliases.
with the list is if you have the brackets with the colon.
colons. Yes,
Yes,
exactly.
exactly.
So if we do this operation right here,
Yeah, so that was
what is x going to be?
1, 4, 3.
Yes, 1, 4, 3. Because if we change either x or y, in this particular situation, it changes both of them because they point to the same thing. Okay? Now, the way we get around that and the way we don't change the original list or the original dictionary is if we do this right here. So now we have, this being 1, 4, 3 right now. Let's say I want to make it so that if I change y, I don't change x. I have to make a copy, and we make a copy with slicing. So we'll say y is equal to y, and we have this, and then we have our colons.
Could you also just say x?
That would also work too because they're aliases. All right, so now y is no longer an alias. Y is now a copy. All right. So now if we change y at this point, it's no longer going to change x. So if I said y at position 2 is equal to 7, x is still going to be 143, and y is now 147. Yes.
So you know up there you said if you do x equals ABC, y equals x, and then you do x equals XYZ,
Mhm.
y is still ABC, right?
Yes.
Is that the same for here? No, because the string is immutable and the list is immutable.
Mm-hmm.
So if you did for here, if you did x equals 1, 2, 3,
Mhm.
and then y equals x, and then x equals 2, 3, 4, y would be 2, 3, 4.
The key thing here is the only time aliasing comes into play is when we can use this indexing right here to change something. Now for strings, you cannot use this form of indexing because we can't change anything inside of a string when it's created. Right. Notice that I just have y equals here when I actually made a copy. That changes where y points in memory. So right now, we have this little cloud right here. And when I declare x, we have 1, 2, 3 declared right there. And so I say x now points to 1, 2, 3.
So x equals ABC, like a string.
Mhm.
You couldn't just say x bracket 1 equals 4, and then your string wouldn't change?
No.
Like,
In-
you can make a whole
No,
different-
if you say x square bracket anything equals, that's red text right there.
Strings, you can't do that.
No.
What this bracket indexing is doing is changing the little cloud.
Right.
So for strings, you can't change the cloud. It's not possible.
Right.
You just have to make a new one.
All right, so up here, we had x is equal to ABC. All right, so now x points to that guy right there. And so when we say y is equal to x, it does the same thing that it does down in the other cloud, and it makes an arrow to the same ABC. Now, when we say x is equal to xyz, we go and create xyz here. We erase this arrow that points to ABC, and we now redraw that arrow so that it points to XYZ. Notice that we did not change where Y points. We did not change that arrow. Now, when we do this with lists, when we say Y square bracket 1 equals 4, that says go look at Y. Okay, where does Y point? It points at this list. Square bracket 1 means index 1, so that's that right there. Set that equal to 4. Well, it says, okay, this is a list. I can do that. All right, done. And now you notice that both of the arrows for X and Y are pointing to the same thing still. We didn't change where those arrows point. We changed what they point to. So they're still pointing at the same 1, 4, 3. So that's why both of them, if you ask them what they contain the same thing. Now, when we say y is equal to a copy of y, when we do that, it's going to say, okay, I need to actually make a new entry in the cloud. And it's going to be the same data as that top one. And now I'm going to reassign this arrow and have it point down here. So now the next time we try and change something in y, notice that the x arrow still points at the top list right there, and the y arrow points at this bottom one. So now, when we change this to 147, x doesn't change anymore. The reason that this stuff down here does not apply to strings is because we cannot change what's inside of a string. It's an invalid operation. So we will never run into that problem, ever, with strings. It's impossible. But it will happen with lists and dictionaries. No. Okay, any questions about that?
To make a copy of the dictionary, would you just say like y equals x and like curly brackets?
It's the same thing. Well, actually, no. It's
Dot copy.
yeah. It's dot. There's a dot copy.
What is it?
It's dot copy. We're not going to ask you to copy a
We're
dictionary.
not going to
Don't
ask you
worry
to
about
copy a
that.
dictionary, but it's dictionary.copy. There's a built-in method to do it.
Yeah.
As opposed to that really nice and easy bracket thing. Is there a list.copy?
Probably. Okay. Recursion. Everybody's favorite.
Love recursion.
Since you
Which,
have been,
you said you wanted to look at one of the test questions, correct?
The test questions?
Both the test questions. All right. What test was it? Which was the first one you want to look at?
Test 1 was easier.
Test 1 first. Can I open up?
yeah, go for it.
All right.
Oh, look, there's your response rates. I wonder if they've gone up.
Ooh, is that this one?
Hmm?
Nice.
Hmm? When you open up that,
Which one do we want?
Scroll.
I have to go up, don't I?
yeah. There it is.
Exam 1.
All right, print that.
Print?
Yeah. Print to OneNote
Oh, you
2011.
can print to OneNote?
Yeah, that's how I get all the PDFs into
That's
OneNote
pretty
so I can draw on
boss.
them.
Do you have to just get a driver?
It installs it with OneNote, so scroll over.
Preferences?
Nope.
Nope.
That's my
Here,
Xerox.
I'll let you do it. Do it quicker.
Ah!
Change Xerox, yeah!
Nope.
Send on? That's kind of cool, I guess, if you're into that sort of thing.
While that's doing its business.
Refresh.
Yeah, it's at 58%. Yeah.
Is it 58 now?
Yep.
Yeah.
It's like double.
Please add this at the bottom.
Adds it in the middle.
Or adds it at the top. That would be horrid.
Be better than the middle.
That's very true. Yeah. Okay. Oh god, this is going to be huge. All right, what page is the recursion question on?
Awesome.
2, 3, 4, 5, 6, 7. All right. And now we wait.
No. I don't know why no one likes recursion,
It's fun.
except for it's a pain. It's not really a pain, it's just time consuming. We had recursion on the first test?
Yeah. This one.
Oh, okay. Alright, so the very first thing we see is we got this function. We see that we have these two calls right here to the same function. So we automatically know that this is a recursive question right there. So we look to see what's called at the bottom, and we've called recitation or res 5. So we have our little box for res 5. And we look, we pass 5 into the function. So right now we have n equals 5. And that's before we've really ran any code in the function. That's just what n starts off with because it's a parameter. So we check, is it 5 less than or equal to 1? Well, no, it's not. So we skip that and we print n. So the first thing you should see on the screen is 5. Now, value equals, oh man, this is going to be a pain. Value equals res at n minus 1. Well, n minus 1 is 4, right? So we're going to, I don't know if I'm going to big enough box.
You want to teach a functional programming?
R at 4. Yeah, let's do that. R at 4 plus R at 3. So at some point, we need to know what R at 4 is, because we need to know res at 5 minus 1, which is R4. We also need to know R of 3, right? So the very first thing Python's going to try to do is get R of 4. Yes?
What always trips me up with recursion is when you have like value equals REC n minus 1 plus REC n minus 2. Like, how are the
What's
like,
the order it goes in?
Not only what's the order, but like, how do we assume just to start off with REC 5 and print that?
Because right here, when you call the function, that's where it starts with. So this is why we said n equals 5. That was just what the
Because that's the
programmer
first
wrote.
place it's called.
Yeah, so you first call REC 5. Like, that's the very first thing you do in the function.
Well, I notice it's indented, it's not indented. So what is that? What does that mean?
So remember the Python shell? If we go over here, we can do stuff, print, like that.
Yeah.
And how when we wrote this code over here, we have a definition. If we wanted to call this function, we would have to call it on the far left. So split string of A.
Oh, I meant by what does that mean? Like, how would it be different if it was indented?
Nothing would print out to the screen because you never called recitation at 5.
That would be a lovely trick question. If we
That
indented-
would be nasty.
If we indented that, not only would result of REC of 5 never happen because it's after the return, which is problem number 1, but it would actually never call REC in the first place because there would never be an initial call to the function.
So nothing would be printed because nothing would run. What's printed to the screen?
If you
Nothing.
write anything, it's wrong.
I mean, unless you say nothing. I mean, you could probably say that.
Yeah.
But that's how you know where to start, is that one line right there.
All right, yeah, I see that. But right past that, now I'm like, how do we assume just to go to REC? We have REC 4 plus REC 3. How do we know just to continue with REC 4?
Like, how do you know to keep going back to the function?
How do we know to go back to the function with the value 4 stored?
All right. So when we start the function call, the method header for REC says REC at n.
Right.
When you call REC of 5, that means we have an n variable right here pointing to the 5. right? So n is 5. We do this if statement, and, all that nonsense. We get to REC of n minus 1. Well, right now, we have an n that is 5. Right? So our n equals 5. We want to know n minus 1, which is 5 minus 1, which gives us 4. That's how, this 4 right here is what you put into REC at 4. And then the same thing for the bottom one. It's just instead of doing n minus 1, you do n minus 2 equals 5 minus 2. This gives you 3. Right? And you'd put the 3 over here. And that's where you get those numbers. That's how you know which one to call next.
But then neither one of those are less or equal to 1, so you just have to keep
You have to keep going, yes. This one's kind of ugly. This one has 2 recursive calls.
That n minus 1 is pretty much the terminating condition for the recursion, right?
Yeah, so your terminating condition is if n equals 1 or it's less than that. So,
because it never gets to the return value statement.
it hasn't...
So you just keep going back up
And
until
it's going to keep recursive calling, so it's going to say skip this, recurse, skip this, recurse, and keep going until it hits this.
Yeah.
When it hits this, it's going to come back and go back up, basically, eventually. So our next thing is we're going to have another block for our R at 4. We do the same thing, n equals to 4. 4 is not less than or equal to 1, so then we're going to print n, which is 4. Then we do another recursive call. So REC of 4 minus 1 is R of 3 plus REC of 4 minus 2, which is 2. Now, we're right here in the recursive call up top. Okay? We're still trying to find R of 4. Now, Python says, I don't know what R of 3 is. I need to know what that is. So it's going to go down. Say, okay, let's do R of 3. Our n's going to be 3. It's not less than or equal to 1, so let's print out 3. Now we're going to do another recursive call. So we have REC of 3 minus 1, REC of 2, plus R of 1, because 3 minus 2 is 1. Well, Python still doesn't know what R of 2 is, so it's going to come down here to R of 2. So n's going to be 2. We look at our function. N is not less than or equal to 1. So that's not going to happen. It's going to print n, which is currently 2. And then we're going to recurse one last time. So 2 minus 1 is 1. Plus 2 minus 2 is 0. Now, we're going to go down, recurse. We have n equals 1, but at this point, 1 is less than or equal to 1. Right there. So, this recursive call stops right there, returns 1. Remember, anytime you hit a return statement, it stops. This is going to go back up right there. So Python is now looking at this 1. It says, okay, I know what R of 1 is, it's 1. Then it sees the plus sign, it says, oh, now I need to know what R of 0 is. So
By it's 1, do you mean the value stored inside, or do you mean...
where's the...
We mean that Python, whenever it sees REC of 1, or where it sees REC of 1 right there, it's going to substitute that with the number 1. Because it knows, hey, I found out that REC, parentheses 1, parentheses, equals 1. So therefore, when I see REC of 1, I'm going to basically cross that out and write a number 1 in right there.
So next thing it sees is this another call. So it makes another box for r of 0. N equals 0. Well, we get the exact same case. 0 is less than or equal to 1, so it's going to return 1. So you're going to go back. We now have 1 plus 1. Python can do that. That 1 plus 1 is going to be 2. So Python just found value, right? Value is 2. Python says, okay, I'm going to return value. Now, it's going to return this 2 back up to this r of 2 call. So it says, okay, I know what r of 2 is. It's a 2. Now, I need to know what r of 1 is. So it makes its recurse call, which we already did that one. I don't have room to... crap.
I mean, just go equals to the side.
Does Control Z not work in OneNote?
It does. I think it just decided that it was going to take you back up top.
Yeah, okay. So what would happen is it would create another recursive call with another box. I'm going to make it point over here. But it would do the next recursive call. And you would find out that, hey, it's 1. So we get value equal to 3. Right? So that's cool. We get value equal to 3. We return value. So it's going to make this return up here. So now Python is, okay, 3. Now, it doesn't know what r of 2 is. So, r of 2.
And we've printed nothing since.
Right, remember that if you look at your code, if it hits this first if statement,
Right.
it hits that return, there's no print. It's only if you have to do an actual recursive call that there's a print.
Right.
So we've done r of 1, and r of 0, and then r of 1 again. But we haven't actually had to, do 2 boxes down or recurse yet. We hadn't had to get past the if statement. However, we now need to know what r of 2 is. So let's make our little box for r of 2. N equal to 2. N is not less than or equal to 1. So the next thing you should see is a 2. Then you do 2 minus 1, which is 1, plus r of 0. Then it's going to do the recursive call down here to r of 1, and it's going to get 1 back. It's going to do the recursive call down to r of 0. It's going to get the 1 back. So you have 1 plus 1, which is 2. Note that this is the exact same value we got as right here. Right? So r of 2 gave us a 2. This r of 2 gave us a 2. That's good. It's what we want. So we add our 2. 3 plus 2, Python can do that. So it gives us value of 5. And it's going to return this. So return this back up to here, and we've got 5. Well, now Python needs to know r of 3. And you disappeared for some reason. So r of 3, n equals 3. 3 is not less than or equal to 1. So we're going to print out 3. Do r of 2 plus r of 1. Well, Python doesn't know what this is, so it's going to recurse. R of 2. N equals 2. Well, 2 is not less than or equal to 1. Let's print 2. So we go to r of 1 plus r of 0. We've already seen both of those recurse. That gives us 1 plus 1, which is 2. 2 turns up here.
This question was only worth 5 points.
Yes. R of 1. R of 1 does its call. It finds that it's 1. So we get a 3, which is good because that's a 3. It's what we want. 3 comes back up here. We get 8. Now, we finally got value at our first little box. So it returns 8.
Question?
Why do you have to find R3 again if you already know it?
So there's a little something called functional programming, and the thought behind that is once we find the result once, we don't ever need to do it again. But in strict Python, the way we have written this, it will have to go back and run all of that code again because it doesn't ever save the result of those lower calls. Dr. Summit did an example in class one day where he used a global dictionary. Yeah, he used a global dictionary to store each one of those sub-results. I believe it was for Fibonacci sequence or something to that effect. And so he would store all of those lower numbers so that if you asked for a higher one, it would never have to keep going recursively unless it didn't know what it was. But we're not doing that here.
So yes, you can. And it's extremely faster. If you ever actually code it, that's what you would do. But this doesn't.
Yes.
Yes.
I made like a web, like going down like a chain, you know?
Mhm.
Yeah.
I just wrote like record 5, and I drew 2 arrows and it says record 4, record 5.
That would
record
be,
3.
yeah.
If we do all that, when we like read in the print function though, will we read it in this way instead of like each layer?
You're going to start at the top, read down to the left.
You're going to go all the way down left, come back up.
Yes, up 1, then down to the right.
So what you're actually making is called a tree.
Yeah, could you show it with the tree?
So, yeah. So we have R of 5 is where we start out, right?
Yeah.
So you would make 2 things for R of 4, R of 3. This one would split off to R of 3, R of 2. This one would split off to R of 2. That's an F. R of 1. Let's make this not an F. R of 1 is going to terminate. R of 1, R of 0. This is going to become R of 1, R of 0. This is R of 2, R of 1. This is R of 1, R of 0. This is a tree. Basically what you would do is go down the left
Okay.
this way.
Yeah.
And you basically make an outline of the tree. It's the easiest way to remember this. Come up, around. So you make your outline of your tree. Ooh. Now, you put little tick marks. This left side. This is what's going to run. Whenever you hit a tick mark, when you're going around the tree, it's going to run that. So the first thing you're going to run is R5. It's going to go down to the left and says, oh, hey, I hit another tick mark. Let's run R4. It's going to go down to the left. Hey, I hit another tick mark. It's R3. Going to go down. Hey, I hit another tick mark. It's R2. Or you could just remember it. You always go to the leftmost one until you get to the end.
Start at the top, go left, then go back up 1, then go to the right until you can't go down anymore.
Yeah, so you go all the way down this way, down here, 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 here. You can't go left anymore.
So you go to the right.
So you go to the right one, then you go back, you recurse back up. You go to your right, recurse back up. You go to your right, but it's not terminating.
So you can go to the left again,
So you go left, down,
and then the right.
go back to your right, come back up, go to your right, up, I'm not terminating, go to the left, up, not terminating.
Oh, that's a lot better. That's quick.
That's a tree traversal. That's depth
Pre-order.
first search?
Is it pre-order, post-order, in order? I think it's in order?
No, it's not.
It's not in order.
It's-
Okay.
Anyways.
There is a specific name for this tree traversal that we learned in 1332 and subsequently forgot. So,
That's a good strategy for any recursion problem.
Yeah.
Because
If
what-
this makes sense to you, go ahead and use this.
Because what you can do is for any problem, you could just draw this tree out, and like let's say we have to print stuff, I'm like R5 greater than 1, print R4, print R3, print R2, R1 nope greater than or equal to.
Mhm.
We give a return statement, keep on going around, keep on going around. R2 print, keep on going around. R3, R2, and those are the answers. That's what's being printed.
Yep.
So, all right, I'm going to do that from now on because the box thing is a little time consuming.
Yes. The only key is to remember where you end. So, when you hit less than or equal to 1, that's when you stop making the tree, right?
Right.
So you stop at 1 and 0.
all right.
So that R1 on the farthest right is the very last one to get called.
The very last thing that
That
gets
thing
called
gets
is
called
this one right there.
That,
Yes,
yeah.
that's the very last one to get called.
Yes.
After that, it's just going back up.
Right.
Okay. So that's all for that question. Any more on recursion?
Recursion.
The print one? Exam 2? Okay.
Oh, is that the start recursion where there's 2 functions?
Yeah.
This one has recursive functions.
Hmm?
This one has recursive.
You don't like?
Please.
What? Why
If
would
there was a
not let me-
recursive call inside a recursive call of a different function.
Okay.
What if we made you do REC of 100? We wouldn't make you do that. Your computer would take forever to do that.
Unless you use dynamic programming.
Yeah.
I've got a good exam problem. I just thought of it. Oh, yeah.
Oh man.
Oh, man.
What are these things up on the roof?
I don't know.
Well, are you gonna go over the XML review question?
Yes, we are.
We will. Yes.
I tried to open the website to look at the code, but it didn't let.
Oh, yeah. That's because that website doesn't actually exist. Remember, it was supposed to be a sample paper problem. I didn't actually put that on the web because, number one, I didn't want you doing it with your computer. And number two, because I thought, oh, well, they're just going to do it on paper, so...
Oh, did you give them like a...
Yeah, I gave them a dummy website name. Oops.
Win.
What page is this? Yeah, it didn't work.
Because I did it on paper at first, then I was trying to check it on Python, but then it didn't let me open.
I think we should do this one as the tree as well.
Yep, let's do this as a tree. Let's see, pages number 6. I'm not going to insert the entire thing
Oh,
again.
you don't want to insert the entire thing.
No, because that takes a long time. And I stupidly called
It's
this
pre-order.
exam
'Cause
3
it's-
review session. Like a dummy. Alright. Alright, pretend you're the Python interpreter and the following code has been entered and executed. Write what is printed to the screen beside the code. So here's our foo, and then there's funct under that. So we go down to the bottom to figure out exactly what we need to run. And we see foo of 3. Alright, so this is our recursive one. That's the one we're going to do. So, this guy right there. Alright, so now we know that we're calling foo of 3. So that's at the top of our tree.
Second one should have been called bar.
That would have been funny. Okay, so it's asking what to be printed. Alright, so technically I shouldn't have written this here, but whatever. Alright, so we're going to have start recursion. And then it's going to print the number that we were given, which is 3. Okay, if num is less than 0, nope, that's not true. If num is equal to 1, nope, that's not true either. So now it says final is equal to foo of num minus 1 times 2. So foo of num minus 1 is going to be a recursive call. So now we go down 1.
Draw your little arrow. This is going to be a much easier tree. There's not 2 function calls. So the recursive function is a little bit easier on this one.
All right. So then we do foo of 2. Now when we go down, we do foo of 2. The minute that we hit this right here, we have to start doing foo of 2. Well, I can't draw a straight line to save my life. We have to start doing foo of 2 right now. Okay, we can't finish foo of 3 until we know what foo of 2 is. So now we do start recursion. And then we print the number. Num's not less than or equal to 0. It's not equal to 1. So now we do foo of num minus 1 times 2 again. So num minus 1 in this case is going to be foo of 1. So now we go back up to the top because we have to figure out what foo of 1 is. Start recursion. Bam. And we print out the number, which is 1. It's not less than or equal to 0, but it is equal to 1. So now we're in this part right here. It's going to print close. And then it's going to return 1. So right now, this is done. That's equal to 1. Okay? So now what we're left with is 1 times 2 is equal to final. Okay? So now final for foo of 2 is equal to 2. 1 times 2 is 2. So then it prints test, and then it returns final. So this right here returns 2. Now we go back up to foo of 3. So now we have 2 times 3, because it replaces foo of 2 with the number 2. So we have 2 times 2. Yes, 2 times 2 is 4. So final is equal to 4 for foo of 3. So it's going to print test again. And then it's going to return 4. So now foo of 3 down here gets replaced with 4. So now it's going to print 4.
Note, if you had just said foo of 3 there and not print foo of 3, it would not have actually printed the 4. Okay, the only reason you see the 4 on the screen is because it's a print in the function call. If you look down here at the, when you call the function foo of 3, there's a print statement.
Yes.
I thought we were saying if we do print and then return right after it, it doesn't print it. I guess with the parentheses, that's okay.
Well, here's
Kinda like returning full.
notice that the print statement is around this function call down here. It's not on the return. Okay, if we printed like this, if we did that, that's not valid. But this is around a function call. That's okay. That's good. This, no.
So even if it goes down there, if I said print parenthesis return 4, that would not be valid.
No. And that would be doubly invalid because that's not a function either. So it would be like returning when not inside of a function. That's a no-no. Okay.
It's very bad.
So that is recursion in a nutshell.
As a side note, can you scroll back down to it?
Yes.
In our case, this tree is a lot simpler because there's only one recursive call. If you had, other ones, so if
5 recursive calls.
plus foo of num minus 2 or something,
Then we'd have our binary tree.
then you'd have something that looked, instead of, it'd have foo of 3, foo of 2, foo of 1. If you had another one, num minus 3, you'd actually have 3 of these.
And the go left and then go right one rule
Still
works.
valid.
Still works.
You can literally have as many of these right here as you want.
And you said function operations are before any mathematical operations. Where you have like foo of 2 times.
Whatever, it'll do the parameters of the function first.
Okay.
So this num minus 1 is actually done first.
And then the function itself, and then times.
Yeah.
Yes.
So num first, that's 1. This function call is second. And then finally, this times 2 is third.
Can we do the second recursion?
There isn't a second recursion.
Oh,
That's looping.
This is looping. I mean, if you want to do it, we can. But this is just code execution.
It's also up on the recitation recording too.
This whole thing's on rotation recording.
Mm-hmm.
Okay, when the for loop runs for the first time, the recursion runs for the first time, wouldn't it print test and then return final, since it's like doing the recursion code, like that's not.
Well, we did print the test for that particular one right here. This is the test for the first call from foo of 3.
So that's understood to be on first.
Right.
First call, right?
Right, but remember that we can't finish doing the test. We can't go down here until we finished this line above it. And to finish the line above it, we have to do the recursive calls.
Why they're all in the same indentation? Why wouldn't like that line one? They're on the same indentation.
Well, the reason why is because Python executes this linearly. And so what that means is that we cannot continue to another line until the line that we're on has finished. And so to be able to finish this line right here, we have to call foo of 2. And then it has to call foo of 1. And that one finally returns, and so they eventually all get back up and they finish.
It basically has to wait till foo of 2 is done.
All right.
Recursion.
Yeah, that's fun.
Just get the answer to the def funct num, the second.
Mm-hmm.
Yeah, can you just run through that?
Yeah,
again?
which is just like, yeah, just real quick.
All right. We're going to cheat. We're going to use the answers.
Yeah.
All right. Too far.
Actually, I think the answers are really printed terribly.
Oh.
It's like it's right there.
Yeah. Okay. All right. So everything from here down is the answer to the second one. All right. So what happens here is we start off with the loop being true. So it starts off running. So it prints off loop running. Okay. And it gets passed in a number, which is 11. So 11 modulo 3. So that's 11 divided by 3, which is a remainder of 2. So that's 2. Equals 0. That's not true. So it says num equals num minus 1. So now num is 10. So then it prints fun. We go back up to the loop because go is still true. That loop is still executing. So now it prints loop running. If num modulo 3, remember num is 10. So 10 modulo 3 is equal to 1. That's not 0. So we subtract 1 from num again and print fun. So now num is 9. The loop is still true. Go was never changed. We print loop running. 9 modulo 3 is 0 because that's evenly divisible. So then it says go is equal to false. So now this loop will never run again. And it prints change go. Now num is decremented again.
I saw a lot of people forget that num was decremented there. Just because you change go doesn't mean you stop your current loop. You still have to decrement num.
Right.
So
Because
instead of 9, you should have 8.
right. Notice that this num equals num minus 1. That decrement is not inside the if statement. That's the key thing to remember. So then it prints out fun right there. And now go is not true, so that loop doesn't execute again. And then it returns num.
And
And the finish never gets printed. Uh-huh. Okay. That's done. All right. Now then, nested loops. So, when will we want to use nested loops in general?
You're having to iterate through a list of lists.
That's a good time. Or when, let's say, for example, we forgot the end keyword earlier, and we had, let's say we needed to check and see whether a string was, or a particular character in a string was, in uppercase or whatever. So we had that string that was all the uppercase characters. We would need to use a nested loop there. The reason being, because we have one loop that's going to go through our original string and pull out each character from that one. And then we need another loop that's going to go through and pull out all of the characters inside of our list that has all of our uppercase characters and see whether they're equal. But most of the time, you're going to be using nested loops for a list of lists.
Do we want to find the average of a list of lists? Find the average of each row or something?
That's in their homework.
Oh, yeah.
Okay. All right, so let's say that we have a function. I'm going to call this def,
I can't think of a harder one.
AVG
It's gonna be the
row.
hardest one they have to do.
Okay, and then we have, I'm going to say this is table. All right, so this is our function. Table is a list of lists. It's made of numbers. You need to find the average of each row and return that as a list.
We want to do this with nested loops.
So we're trying to find the average of each row and return that as just one list of all the averages.
Yes.
You have to do this with nested loops. That's the rule.
Well, yeah.
All right.
I said my questions last night.
Yeah, I saw that. It got to be late last night, and I just decided
It was 4:30 and I was about to go to sleep and I was like, oh crap.
test questions.
Test questions. So, fell asleep at 8 o'clock this morning. Woke up at 1 o'clock. 1:30 rather. Packed up my stuff and drove over here.
All right, so when you get done, raise your hand. Oh, yeah.
It's an interesting seat.
Mhm.
Stool thing.
I know, it makes me happy.
But no, I've never had a class in this room.
I taught my last summer's recitation in this room.
Not a bad room. Feels very CSy. Like there's this huge wire cord.
This table is just a list of lists, and it has numbers in it. Yeah. No invalid data. You know, now that I think about it, we've made life really easy for you in all the code writing problems by saying there's no invalid input. Man,
Yeah, yeah.
change that.
No, you shouldn't change it.
What happens if they're strings? Yeah.
They're all integers, right?
Yes.
If you did, we'd have to do like a try except for
Try or accept, or you could check the type
If.
before you do it. So you could say
I
like
would check
if,
the type.
Yeah, if type, of whatever that thing is equal to int or something to that effect. Yeah, that's what I do.
What is this thing over here?
I think it's a TV.
Go inside.
It's got a keyboard on it. It's a lot.
really stupid shit on it.
That'd be awesome.
All right, does anybody have the answer for this? All right, care to give it a whirl? Does it work? Okay.
Wait, we have to use nested loops?
Yes, you must use nested loops. I know you could do this with some and LEN, but that's cheating for this particular problem.
I'd probably use LEN. That wouldn't be bad.
Hmm?
I'd probably use LEN. I'd be okay with
Okay, yeah, LEN is fine, but some is not.
Don't use some.
Don't use some?
No. Use nested loops.
Are you gonna say that on the test? Like, you can't use some?
It's perfectly, yeah, it's perfectly possible for us to restrict your use of certain things to test you on other things. All right, I'll start writing it up here.
Ooh. Mallocating, reallocating.
Yep, there was a 2110 session in here.
I definitely don't ever use realloc.
I don't either.
I don't know why. I use a temp var, and malloc space to it. It should be on the same dimension.
Yeah, it should. Thank you.
I mean, I know what you're going for, but
Python doesn't.
hit erase this here. I want to put it in. Wow. On that people monitor. That would be awesome.
Get out of the.
So another way of writing your second for loop, you could also do for item in table and then bracket row.
Say that again?
That's like instead of writing for item in row for your second for loop, you could also write for item in table and then bracket row. That's the index for stuff.
Not quite. You'd have to change the first for loop to be index numbers.
Okay.
Right now, row is the actual
The actual
list.
value.
Yeah. If you had indexed it, you could do it that way.
Bam. And that was one of your functions from homework 5. Man, doesn't that just burn? Oh, man. All right. So, what we did here was we wrote our function definition, def average row, and then we gave it our list of lists. The first thing I started off by doing is creating the list that we're going to append our averages to. And then we say for each row in the table, because remember this is a list of lists, so this outer loop right here is going to pull out one list at a time. So then I initialized a variable inside of that loop called row sum. Now the reason I initialized row sum to be 0 at the top of that loop before I did the second loop is I need row sum to go back to 0 at each new iteration, because we don't want to keep making the sum go up over and over and over through each row. So then I said for item in row. So that's going to pull out one item from the list that we pulled out that's row. So that's a number. And so then I said row sum plus equals item. So that's going to take, row sum equals row sum plus item. So it's going to add each item to that. So that's all I do in that inner for loop. So I get out of that for loop, and after that's finished, row sum is equal to the sum of that entire row, that entire list. So then what I do is I append that to averages list, and what I append is not just row sum. I append row sum divided by the length of the row, which tells us how many items there were in it. Question?
Yes, when you're doing row sum plus, is it the same as row sum equals to row sum plus item?
Yes.
It's the same.
Row sum plus equals item is equal to the same thing as row sum equals row sum plus item. Right, so then outside of that outer for loop, I return averages list, and that's the solution to the problem. Hmm? You can. All right, so that's nested loops. And I believe I want to go over XML quickly.
XML.
Could we ask some questions about the exam 1 stuff before you move on, or should we do that after?
What kind of questions about exam 1 stuff?
I was just gonna ask, what's the minimum requirement for a valid header, and then what's the minimum requirement for a valid function?
Are the solutions posted?
Yeah, the solutions are posted to exam 1 and exam 2. They're on the class website.
Oh, is that the question to exam 1? I looked at it at fall 2010 exam.
It should be
Yeah, it's
posted.
right here.
Our solutions are posted.
The fall 2010 exam 1 is right there.
Yeah, I mean, I looked at the answers, but multiple choice part B.
Wait, what the?
What?
That's not very nice.
Who wrote this?
Jay?
Oh, this is.
It's horrible. All right. Which question?
Multiple choice part B.
All right. All right, so which of the following statements about functions is true? Okay, so all a function needs is a header to be a valid function. So the only thing that would be there would be DEF and the name and then empty parentheses colon.
Okay.
All right.
That's a valid.
That is not a valid function. That's not right.
Pass.
You need at least one line indented under the function. So that can be as simple as pass or a return and then something in the return.
Yeah, that was my question.
All right. So a function can be defined in another function. Yeah, it most certainly can, but you don't see that too often. Once you write and debug a function, you can reuse it. Yeah, that's the whole point of writing a function, is so you can reuse it. Oh, this is back in the day when we didn't use multiple correct answer questions. Oh.
Yeah.
Um,
Nice days. Yeah, it's the worst. Actually, I kind of like this one. How about part, you know, on part C of code reading C. Could we do that one?
Oh god, he's code reading.
all right.
The value that I'm getting is not that.
You know what I'm saying? Like, there's gonna be one or the other one. Yeah. There's circle all
Hate
three.
these
You get one and a half.
Answer double checking.
Circle one.
Oh, there you go.
No!
See, like, I don't understand like how like everything went out.
All right. So here's how this one works. So we call what do I do with
This wasn't like a final purpose.
what?
There wasn't a lot of parentheses.
Just put it in the demo.py file.
Whereas needed like
There you go. Yeah, right there.
Okay. So that didn't work very well. All right, so let's just run through this by hand. So we do what do I do? Hello 15. We haven't really talked too much about optional parameters this semester, but this right here is an optional parameter. That says that if we don't specify a second thing down here, the default value is 0.1. But we did specify a 15 down there, so that 0.1 is a 15. Right, it's a 15, not a 0.1.
So it automatically changes to a 15 then.
Right.
Um,
If we had left this off right here
You just said hello.
and just said hello, it would be 0.1.
it's still the answer. Actually, let's just. Can we still like?
Yeah, okay. So, this is page 5.
How about if 0.1 was not there?
If 0.1 was not there, then it would require us to put something in. For this particular problem, it doesn't matter because we specified the value, so it would be the same thing. The answer would be the same for this problem. This is page 4, right? I
Yeah.
hope it
The
is.
key difference is if you put the equal sign, you don't have to give it a parameter. If you don't put the equal sign, you must give it a parameter. So a lot of those functions you use, like the range function, where you don't have to give it a 0 in the beginning, that's using default parameters. And that's how they do that.
All right. So, what we're going to do is we call what do I do hello 15. So we say hello 15. That's going to be, all right, so,
Num 4 is
it's gonna be-
hello,
all right.
and num 2 is 15.
Oh, this is one of those tricky ones. All right, so num1 is equal to 1.0, comma, hi, comma, roar. All right. Num3 is equal to num1. Now, this is an aliasing question.
We know that because we have a list, and then we do an assignment to that list. You should automatically take aliasing.
All right, boom. All right, so now num1 points there. Num3 also points there. If num4 equals by or see ya. Trick question.
This does not do what you think it does.
That's what it was. That's why the value
Wait, say that one time?
becomes.
This is a trick question.
This doesn't
This
do what you
right
think
here-
it does.
Yeah, you
This is always true. This is not an error. This is always true. Always.
That's why I was confused.
So
Wait, why is it always true?
let's go to
Because
Python.
Python says it is.
I'm honestly lost.
Yeah.
Here you go. If a string.
Yes. Yes.
Print. This is true. Else. This is false. Note our if statement has a string in it.
All right. Let me write out that true-false matrix because I think it might actually help you to see this. All right. Okay, if we have if true, that's true. If false, that's false.
We don't need the parentheses, right?
No,
No.
you don't.
All right.
Some languages do, so if you see us doing it, that's probably the reason why.
If 0, that's false.
If empty quote.
If any num that's not equal to 0, that's true. If
So if you say if 5, that's true.
Okay. Is that a space or just empty?
That's
Yeah, it's empty.
That's not a space.
Is that even works for negative numbers?
Yes, if you say if -1, it should give you true.
all right. So that is the truth table for pretty much. Actually, I forgot lists and yeah. Oh, fiddlesticks. All right.
Is this false?
This is false. If it's not empty, it's true.
Dictionaries work the same way.
Mm-hmm.
Tuples.
Dictionaries and tuples work the same way. If they're empty, it's false. If they're not empty, it's true. Yes. Question? Okay. So, that is what you need to know to solve this problem. So, if we look at this again, it looks like if num4 equals by, it doesn't, or sia, which is true.
So you get false or true.
Uh-huh.
Let's do the actual
All right, so truth table. All right. Yay, truth tables. All right, so
Also true is always true.
What comes first, and or
ooh.
And always has precedence over or.
Okay.
Yeah.
All right, so T is it that or yeah,
Just say
whatever.
or. I don't think they.
T or T, that's true. T or F is true. F or F is false. And F or T is true. And T and T is
You'd actually
true.
make it F or T, F or F, if you really wanted it to be a
one person like
table.
That's not even a letter.
It's a symbol.
All right, T and T, T or F. What? What?
F or F.
Yeah.
You put or.
Yeah. Starting to pick up some James here.
Oh, you're talking about.
F and T is F. F and F is F. Okay, so that is our truth table for our Boolean operators, and of course not is exactly the opposite of whatever's there. So if you have a T, it becomes an F. If you have an F, it becomes a T. It's pretty straightforward. So there's our truth table. So now we go back up here and look at this. By the way, I don't think we're going to ask you any questions that ask you order of operations between and or. No, that's
We're not going to ask you that.
yeah, that's true. Jay reserves the right to make us a liar.
So we're not
As
going to
usual.
ask you that.
Exam 1.
Right.
Yeah.
What, there was one of these on exam, on
Yeah.
your exam one?
Yeah.
It was a multiple choice, like, not true and not false, true or false and false. True and false, or not true or false.
Actually, I think I might have written that one.
Yeah, well, and at first I thought they were all false, so I was stressed.
Oh, okay. Yes, Anthony is correct. And takes precedence over or. Okay, but in this particular case, all we have is two Boolean expressions connected by an OR. So this guy right here is false.
Hello equals by is false.
But this right here evaluates to true according to our rules right down there. So we have false or true, which is true. So num3 square bracket 0 is equal to num2. So num3 square bracket 0 is equal to num2. That becomes a 15. That else doesn't run, and now we return num1, which is this list. And so when we print it, you should get 15 comma high comma roar.
And where in the code, I get everything except for this one little thing. When in the code do they say or Sia? When is Sia ever mentioned?
It's just a string.
Just a string.
It's just a string they pulled out of thin air.
So if they had had a variable for it, somewhere right here, they could have said var equals Sia.
So if C is always going to be true.
And then you could have said or var.
If any string,
It would be the same
Not
thing.
empty is
It's
always
just a
true.
string.
So that statement will always run.
Yes. Irregardless of what num4 is.
yes. You can. This can be true or false. It doesn't matter. This if statement's always going to run.
Yeah, but that else statement will never run.
That
That's
else
correct.
statement will never run.
Yes. Oh, conditionals. I love you so. Sure can.
And you learn this in discrete mathematics.
Yay, 2050.
And then you get into exclusive ORs and
Yeah.
biconditionals and
Woohoo!
if-then statements, and it's fun.
All right. What else? Yes.
Can we review, like, very quickly basic file I/O and then jump into CSV file I/O with an example where we have to import everything and work it correctly?
Sure. All right. Does anybody need this table anymore? Still writing?
Are we going to do
All right.
CSV first or XML first?
Can you actually scroll up to the list of all the
Yes.
Yay, Python being...
This harkens back to the days of C, where there is no true and false. There's only 0 and 1. Or more appropriately, 0 and everything that's not 0.
I never understood why they had a Boolean type in C. Like why they actually called it Boolean.
There is no Boolean type in C.
Bool?
There's not. That's in C++.
Oh, that's in C++.
CSV right has right row and right rows. Then F only has F dot right.
Yes.
And then for read, F dot read, F dot read line, F dot read lines. And then for CSV, just CSV dot reader. It's so confusing.
Memorize it.
That's literally all you...
That's what we
There's
told
not
you to
really...
do. Because I'm afraid that there's no other way around that one other than just memorize it.
That's our read line, that's our read lines. And then
Yes, for standard file I/O, it's read, read lines, read line. And then for CSV reader, it's just CSV reader loop.
Can you write that down? Like,
Yes.
Yeah, we'll write that down.
Is there CSV dot writer?
Yes,
Yes.
there is.
That's what we asked you about.
Between that one and the right row and right row. Yeah.
CSV writer uses right row and right rows.
If you don't use CSV writer, you have to use write. And that's it. CSV writer is the one that has right row
So if
and
you
right
guys
rows.
asked for like the possible ways to write CSV, you would say right, right row, and right rows.
No.
No.
Just right row and right rows.
Mm-hmm.
If you import CSV.
Yeah, if it, well, the question would say specifically using CSV writer or not using CSV writer.
Which would you use?
So if we don't use the CSV writer, then it's just right.
Yes.
Yes.
Hint, hint, we asked you that on exam 2, and you all missed it.
Right.
Yay! Somebody got it right.
So not everyone missed it.
Okay.
I got it.
I thought everybody missed it. Okay, I stand corrected.
Right and right are
Empty list.
You cannot use dot write on CSV writer. No.
It will fail.
Row and right row.
It will laugh at you.
Row and write rows.
And then go down to
No.
false thing.
All right.
Follow code. Yeah, and so,
Bam.
follow code while it's true.
All right, standard file I/O. Yay, erasing my letters.
Standard file. We don't have a built-in example.
No, we don't.
Do you want it? Did you want an example of file I/O with CSV, or just like an actual file I/O raw example, or both?
I mean, yeah, I always get tripped up with read lines, read line, and read.
Okay.
I always forget what the differences are.
Can you rewrite the table?
Yes. You want me to rewrite the table when I talk about it?
Which table?
The read lines, read.
Like read line.
Ah, yes. Okay.
Kind of stuff.
Yeah, that'd be good.
If you want to talk about it, you don't have to sit here and look at your screen.
Cool. All right. All right. So, the first thing when we're doing any standard file I/O, this includes your.
Oh, were you gonna put the comment here?
Yeah, just delete the comment.
Gotcha.
All right. So this line right here, when we're reading a file, whether we're using CSV Reader or we're using standard file I/O, this line has to be there. Okay. So that's going to open the file. That opens for reading. If we were going to open it for writing, what would we say instead?
W.
Right. Change that to a W. That's it.
Which
Now-
one's the default?
The default is R.
Reading.
What's W?
WR is nothing.
There
R,
is
yeah,
an A,
which is a pin.
which is append. So writing starts writing at the top of the file if it exists.
Yeah, basically erases everything in the file and starts new. So there's R, R plus, W, and A. The only ones that you have to know are R and W. That's it. So,
If there isn't a file to write, it'll make just a new file.
yes, that's correct. It will make the file.
Assuming you're using writing. If you're using reading, it must exist.
Haha, you're trying to read from something that doesn't exist. I'm going to give you garbage data from dev random.
So just
Oh,
try to
what?
accept that I asked that.
All right, so now for standard file I/O, let's talk about reading.
Oh,
So
why
we
is that
have
going up?
3 methods that we can use for file reading. These only work for standard file I/O, not for CSV Reader. Those are read, which gives you all of the data as one string. Does not split it up by lines, doesn't do anything. It gives you one string.
All of it.
Right, everything in the file, one string.
No spaces or nothing, or?
Well,
Yes, it
it's
gives you
gonna include
spaces.
everything, including all the new line characters, but it's going to include them as new line characters. It's not going to split up the data. All right, so read, one large string. Read line. It reads in one string at a time, so it reads until it finds a new line character, and then it stops. That gives you one string, but it's only going to be one line's worth of data.
The read line, you'd normally, I guess, use that like in part of like a for loop.
Exactly. Or actually, more appropriately, we'd use it in a while loop, because we don't know how many lines there are in the file.
Is it as a string or a list?
It's a string.
Okay.
All right, so that's read line. That gives you one line of data as a string. That's just one line from the file, so it reads until it finds a new line character, and then it stops. And then the last one is read lines. That gives you a list of strings. It reads in the entire file, and then it basically does read line, but it does it for every single line in the file. So it gives you a list of lines. Yes?
List of lines, as in like each line would be another list, right? So
Yep.
it'd be like list
No,
of lists.
it would be a list of strings.
List of students.
And that string is the line one.
Right. So imagine that, for example, read lines is going to use read line in it. Okay. So basically, read lines just prevents you from having to do the whole while loop thing to read every line using read line.
But like, would it, so it's just like a whole list?
It's a list of strings. So each string in that list is one line worth of text.
Would that be the
Yes.
same thing as read, splitting lines into lists?
Yes.
Yes.
It's like you can store a read line and a value. That's each element of the list.
All right. I've got a question for you. when you do read line, how do we know we're at the end of the file?
While it's not empty.
Yes. When you're reading a file and you're using read line, when you get an empty string, you're at the end of the file.
Could you draw like an example of what would happen if we did read lines for a certain document?
What if there wasn't a blank line, it's just legit?
Then it would give you a string that just has a new line character in it.
So if we were trying to get all the lines, and we were using f.read line, we'll have to just
Right.
while the bracket
So it'd be
get all
like while the line is not equal to an empty string, then keep reading.
Right, but if we were using f.read lines, we don't have to use the loop to get all the lines, right?
Right. You just say, you know, lines is equal to f.read lines. Boom. Done.
I don't know.
Right, so, Colleen, you had a follow-up question?
I don't know what ISY classes there are.
Okay.
20.
2028.
Yeah. There's 2 2s in there.
Yep.
I was close.
Maybe we can just make up.
Okay,
That's
so
not as realistic.
if we open up our file, file.text for reading, and we say f.read, this is going to give us one large string. Is it / this way? The other way.
Other way.
I think it's the other way.
I think you're right.
Yeah, there you go.
Yeah, well, 1400, and I'm not gonna have enough room. ASYE.
Oh,
Right,
CSV
and
is
so
the
on.
one with the list.
And so on and so forth. Yes, CSV is the one with the list of lists.
It's like
All right, so that's what that's going to look like. And it keeps going until it gets to ISYE 2028, and that's the end of it. If we did read line, and we only did read line once, it's going to give us what? CS 1803, just that one string. That's it.
It's gonna give you the new line character, right?
Right, and it's going to give you a new line character. Now, if we do f.readlines, that's going to give us CS 1803, new line, and then as the next element in the list, it's going to give us CS 4400, new line, and so on and so forth.
And if you're doing string manipulation, if you want to get rid of the new line, you do whatever the string name is, dot strip, and in parentheses you have the new line character, and it gets rid of it.
Right. Or you can just say dot strip, and then nothing inside the parentheses, and you don't get rid of all the spaces between, you know, in the front and the end.
So it would be CS 1803.strip,
Yes.
and it'll get everything other than what you just put, right?
Right. It'll basically return the same string except without this new line character in it.
So what would you do like 18.strip? Would it strip everything, would it strip away the CS and the...
No, if we just did 18, like if we said 1803.strip or something like that, it just wouldn't do anything to it.
Oh,
The
okay.
only thing-
It strips out white space and new
Yes.
lines by default.
But it won't take away characters?
It won't take away characters.
Okay.
And it will
And
also not take away spaces in the middle of the string.
the spaces to the end.
All right, so that's standard file reading. How about standard file writing? What valid method is there? F.write, that's it. That's all you get. Sorry, there is no F.write line or F.write lines. I swear if anybody puts write line or write lines for anything, anything, I will find you. I will find you.
Oh, stop that nonsense.
Yeah, you are.
That's not good. You're all going to go here eventually. It might not be next semester, but it will be one semester. It will float around here.
Yeah, we might not all be here.
All right. That's all you get. This takes a string. It's the only thing you can put in here. It's one string. The key thing to remember is if you need to split things up by lines, you have to put the new line character in yourself. It will not automatically put one in for you. That's the rule. Oh yeah, and don't try and write to a file you have open for reading. That's an exception. Don't do that. Okay.
What do you do after you're done reading or writing from a file?
Close parentheses.
Open, close parentheses. Good.
Yes.
Do that. Second thing, don't do it after the return statement. That's bad.
Or he will find you.
What if we do an f dot write lines after the return statement? Find us together.
Well, in that case, I would not show your face around this building. It's just not a safe
Do
proposition.
print, return, and then
I think we would just have an aneurysm and just die, and we wouldn't be able to hit you because so much went wrong. Anger, exploding.
Print return f dot write lines. After the return.
Oh, now you're just trying to make us mad. All right.
Oh man.
All right, so that's all of your standard file I/O stuff. CSV.
There is a CSV reader and there is a CSV writer. We have not required you to use CSV writer that I know of.
Pull up just like a little bit. See like the last f dot write line.
F dot write line. What?
F dot write in the line.
Okay. James, you wrote F dot write line on there?
I did not.
What? All right, so for CSV reader,
Could you list the reader? If you list the reader, can you skip the for loop?
I don't know.
Is it a proper generator?
I think so.
First thing we gotta import. What do we?
Import CSV,
All right. Capital or lower letters?
all lowercase.
CSV.
Import CSV. That's your first step. Always and forever, import CSV. Step 2. Same
Step
as
2.
with standard file I/O. Open the file. Now, why do we not just drop that F equals open blah 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 into the CSV reader as the first parameter instead of saying F equals open in the line above it? That's exactly right, because we have to close it, and if we open it inside of the CSV reader, we're never going to be able to close it ever, and then James will find you. Okay, step 3. We need to make our CSV reader. So what are we going to say to make the CSV reader?
Like you store it, like reader
Mhm.
equal to CSV reader,
Mhm.
and then whatever you store the open file.
Yes. All right, CSV.reader. And then inside the parentheses, we give it the file object we opened. Now, we can also put some additional parameters in there, like what character or string, more specifically, separates data. That's called the delimiter variable. You can also specify the quote character,
I can't spell this.
it's I.
I-T-E-R. Yeah.
I-T-E-R.
Limit.
Yeah. Right, so normally, by default, that's a comma. So if it's actually comma-separated values, you don't have to specify it. There's also this thing called quote char, which if you remember from the time lab, one of the examples had that 1, 2, 3 thing in it that you had to display. That string was inside of quotation marks, so that way you can have data with commas in it that's still one piece of data.
What's the default quote char? Is it the double quote or single
So
quote?
double quote.
So there's only one option if you want to read in a CSV file, and that's CSV.reader.
Yes.
And the file name.
Right. So the most simple thing is just this line right here, CSV.reader with the file name. That's the most simple one. And most of the time, that's probably what you're going to be doing because you don't need to change the delimiter because it's always separated by commas. So,
Yes.
I have a question. You know how when we do print, at the end of the print, we always as default, have a new line. How do we change that new line to something else again?
end equals and then some other stuff.
And equals.
So we can put that file in there as not a string, right?
So this F right here is a file object. It's not a string. The string only goes into this file name right here. That tells it what to open.
So that's a string.
This is a string. This file name is a string. This F is a file object. This is something called a file handler right here. Yes?
For the quote chart,
Mhm.
I know
parentheses, wait, can quote chart only contain quotes?
Quote chart can contain any character or string you want it to.
So let's say you want to do the parentheses, right? Then what if, like, do you have to put both?
It can only match like characters. So if you did an open parenthesis right there, then
You would have to put an open
yeah,
parentheses
would
to end
basically
it.
be open parentheses that starts it, and then there would be an open parenthesis that ends it, which is kind of confusing.
I think it'd be awesome.
The other way, regular expressions and not using CSV Reader. Yeah, don't do that.
Regular
the other
expressions
way, if
and
you
not
wanted
using
to do
CSV.
The other way, if you wanted to have a quote character where, you know, things could contain commas inside the quote characters, the only way to be able to use an open parenthesis and a closed parenthesis as your quote characters is if you use regular expressions to do that. No. Yes.
I just have a question. Will there be a code writing regular expression problem? No. Okay.
No.
All right, that makes me feel a bit better.
The reason why is we have never asked you to do any code writing that would require you to use regular expression in homework, so we're not going to ask you to start doing that
What
now.
about code reading?
That's possible.
It's most likely going to be something kind of like exam
Exam
2.
Like a short answer or multiple choice?
Most likely that's what you're going to see with that.
Yeah, reading with regular expression is kind of dirty.
Especially since I would have to figure out how to make it.
All right. So we've made our CSV reader. Yay. Now how do we get data out of it?
Run a for loop,
Run a
create
for
an
loop.
list, and then
Yes.
run a for loop.
Empty list and a for loop. We think you might also be able to directly cast the reader to a list, but I'm not sure about that, so that goes in one ear and out the other.
You said it.
Make an empty list?
Mm-hmm.
Yes.
So it'd be like for row in reader, and then you append into that data list. Question?
You said we don't have to write regular expressions, right?
Well, you had to write them on exam 2. You might have to do it again.
You won't have to do code writing. Parse this CSV file with regular expressions.
No. No.
And only regular expressions.
Okay. Now, last thing we do.
Read in your file as bytes.
Close the file.
Well, the
Close the file. Yes, close that file. Haha, we're done. CSV reading is easy. Just memorize that. Seriously, just memorize that. Done. All right, CSV writing. What are the 2 viable methods to use with CSV Writer? Right row, right rows. Once again, there is no right line or right lines, or dot right for that matter. That doesn't exist.
CSV writer.
Now, when we call right row, what do we have to give right row? What's the parameter we give right row?
something to write it into, right?
Note, creating a writer is the exact same thing as creating a reader. We didn't talk about that.
Right. So basically, if you scroll up and look at the steps
Same kind
to...
of thing, if you try to write in something that doesn't exist, it just creates it.
Yes.
Okay.
You have to open the file like you would normally do, except you open it up as writing instead of reading. And it's writer equals CSV dot writer F. Almost the exact same thing as reader, except instead of saying CSV dot reader, it's CSV dot writer.
Place the word reader with writer.
I believe it also has quote chars and delimiters,
Yep.
but
Same parameters apply. Okay, that's all that. So we have writer.write rows. Oh no.
go to pin, please.
Well, if you quit touching all the keys, James.
If your keys weren't in my way.
Yes, if you don't create a CSV writer, you can use write. That's the only valid way to write to a file that's not a CSV writer. But here we're doing CSV writer, so Okay, so writer.write rows. The parameter in writer.write rows is a list. You have to give write row or write rows. Yeah, okay. Write row,
Thank you.
give it a list. So each particular item in that list is one element in your CSV file. This is going to write out an entire line worth of CSV data. All right. The cool thing about the CSV writer is it will automatically put the new line character there for you. So you don't have to worry about that. Now the second valid one is write rows. What does write rows take? Well, if write row takes in a list,
James, think way backwards. Right rows takes what? Because you're saying right row if you're studying right rows.
yeah.
Is it
Well,
writing?
no, I'm saying write row takes in one list. Therefore, write rows must take in
Oh, list of lists.
a list of lists. Yes.
So right row takes a parameter of a list.
That's the data you want to write out to the file.
So, alright, so you already have created the list or whatever in your code,
Yes.
and then you just say right row, and it'll put it into the, okay.
That's like for the last homework. The easy way to do this would be every time you found a row that's valid, that has an ending date within 365 days from now, that we create a list that has all of that data in it that we need to put into the file, and then just call write row every time we find that list.
Well, couldn't a list be a list of lists?
I believe it can, but
have
it's
a list of-
going to string your list.
Yeah, it's going to make a string out of the list, and that's not what you want.
I'm pretty sure it's
So
going to.
that'll put everything in a list in as a string separated by commas?
No, what it'll do is if you have string of a list like that, it's going to give you this.
It's going to show up exactly like that.
So-
if you did write row of a list of lists, it's going to look like
A bunch of those.
1, 2, 3 inside those brackets like that, and then comma, and then bracket 4, comma 5, comma 6, square bracket, comma, and then square bracket 7, comma 8, comma 9, square bracket, and that's going to be all on one line. Which is definitely not what you want. Don't do that. All right, so that's write row and write rows. And so the process for using this is basically the exact same as CSV. Well, no, that's a lie. You're going to open the file for writing, make your CSV writer, call write row or write rows, depending on which one you want to use, and then close the file. That's it.
Your first 3 steps are almost identical. After you do that, you got to figure out, put your data in a list or put your data in the list of lists if you haven't already. And you can write out to the file. You may have to use a loop if you're doing write row, whatever you're doing. And close the file. Always. Also, parentheses, open, close parentheses. You must put that on close for it to do anything.
Are you guys actually going to ask us no web scraping questions in the final? Because there was like nothing about that on the list.
It's definitely possible. If we do ask you a web scraping, most likely it's going to be, we'll tell you what kind of tag you're looking for, or we'll give you the XML, and it won't be any complex XML. So it'll either be simple XML picture we give you, or we'll tell you what tag you need to search for. So that is all the CSV writers, CSV reader, standard file I/O. You basically just have to memorize each of these and where they go. There's
I don't understand what you mean when you say right row on each of your list.
So the parameter that you give to write row is a single list. So let's say, for instance, we had, a list of products or whatever. All right, we want to put, let's say, the products from each company on one row. Okay, so each row is going to represent one company's list of products. So what we have for right row is we have just a list of product names. And that represents one company. Okay? So there we go.
Some other
Just like
Dell laptops.
that. Latitude.
Attitude.
Okay. So there's our list right here. So we have Dell and then their two computer names right there. All right. So this right here is what we give to right row. We would give this one list. And so it's going to write out Dell, comma, and then Inspiron, comma, and then latitude. And that's the end of the line. And then, if we have another row right here, we'd have to call right row again with this second row, and it would write out all of that. If we did right rows, we would make a list around these lists, so each one of these smaller lists would be inside of a larger list, and then it would know to automatically go through all of the lists inside of this one and call right row on the list inside of that larger list.
So basically, right rows is just gonna kind of pick it up and put it in.
Yes.
Yes.
And right row is kind of like, all right, well, this is what you're giving me, something separated by commas.
Right. It basically says right row is do one line of CSV data at a time.
Yeah.
Right rows is write everything.
Yeah.
And it's going to do multiple lines of data.
Well, so what type is right row? Like once you actually do like the right rows, what's the data type? Would it be a list of lists? Or would it be a list
Right
of
rows
strings?
takes in a list of lists.
And what does it produce? Like,
It doesn't produce
No,
anything.
it
It writes
doesn't-
out to a file.
Right. It doesn't return anything, but what it's going to do is it's going to write an entire CSV file.
oh, okay.
Okay. So, I have another question. When you're doing file reading, either standard file I/O with file reading, or you do a CSV reader, what data type is everything you get back? Because then we couldn't get anything back.
It's kind of a guess.
So if we're doing standard file I/O or CSV reader, what data type is everything you get back? So for CSV reader,
String.
yes.
Even the digits in there.
Mm-hmm.
Okay. So for standard file I/O, when you do read line, or read lines, everything is a string. That's pretty obvious. When you do CSV reader, when you get that list back, or you have your list of lists after you finish doing all the reading, everything inside those lists is what type? It's a string. So if you have any data you need to do something with, you need to convert it if it's a number or whatever.
And can you just go through how to convert it quickly? Because sometimes I do it right, sometimes I do it wrong.
So converting it.
That's usually wrong.
So let's change our file. I'll write it down again.
Oh yeah, and for entry boxes and GUIs, kind of a side note, somewhat related. Entry boxes and GUIs, the data that's in those entry boxes is always of what type? String. Yep. So if you're asking a user to type in a number into an entry box, and you need to use that number in some kind of calculation, you need to convert it before you start using it. That got almost everyone on the last exam. Don't do that.
Don't do what again?
So if you have an entry box in a GUI, and it has numbers in it, and you need to use those numbers to do something, let's say like multiply the number by 2 or something,
Right.
you need to convert that number to a numeric type before you can do that.
All right. So
What's your closing list?
If you didn't do that, that would just put the strings together, right?
If you
Like
need
let's say
Yes.
a number, there was a string, and take another number as a string, or just
right,
put
it
them
won't do
together.
proper math on it. but-
So this is what you would get if you did a CSV reader on a valid CSV file with this data in it. All right, so you're going to get a list of lists with each of these being numbers. Now, depending on the data, you may have header rows or header columns. In this case, we have a header column. That means we want to skip that one when we convert it. Now, The easiest way to convert these is to use indexing. Remember that lists are mutable data types, so we can change them. So instead of doing a for each loop where we do something like for row in data, instead of doing that, what we want to do is create an index. So for row index in range length of data. Actually, I'll put 0 length of data. 0 length of data. So this is a range in a for loop. What is row index going to be? It's going to be a number.
Because of the range part, right?
Because of the range part, it's going to be a number. So you can do this multiple ways. I don't need it. So if we look at our data structure, before I keep going, if we look at our data structure, we want to go through every row, right? But we want to skip this first column. We don't really want it, because you can't int convert del. That doesn't make sense. So
If statement.
you can do it a couple ways. The easiest way is when we're making our column index. Instead of starting it at range 0, start it at 1. What that'll do is when you actually start indexing, it'll skip the very first one because we start at 0. So your next step is to get the piece of, don't use that variable name. Now, how do we get a number out of data, or one of these strings up here? We want to index it. So this is a list of lists. That means you're going to need to index it how many times to get one of those strings? Twice. So our first index, we have two options. We have row index and we have column index. Which one do we want to use first? Row index. The second one, we just use the one that we have left, column index. So we now have a string that's, the first time it runs, it's going to be 10.
Will you explain that last line of code?
This one right here? Yeah. So data, let's actually give concrete values. So
The second LEN is wrong.
you're right.
No, it's wrong.
What?
No, this LEN is wrong right here. And the reason we can't use LEN of data, what? Say that again?
Doesn't have to be indexed.
Yes, it does.
I'll do this legit.
Yes. The reason why is that would work if we knew that our data set was a square. That the length of the rows is equal to the length of the columns.
Right.
But we don't know that.
But we don't know that.
In the example case we have, it would have worked, but don't always assume that.
Yeah, but if you had like more values, like
Yeah, if you had like another number on the end, you would have been screwed. So let's say we want to get this 8 right here. We know it's stored somewhere in data, right? So we need to get it out with the data variable. We said a minute ago that data is a list of lists, so we're going to index it twice, right? So we're going to have 2 brackets, and we're going to give it 2 numbers. Okay? Now, this 8, which inner list is it in? So this is inner list 0, this is inner list 1, this is inner list 2. So we're going to give it 0, right? Inside the list, you have position 0, position 1, position 2, Well, it's at position 2. That's how you would get the 8 out. So we don't know how many rows and columns we have. So we can't just, say, get the data out at 0, 1, 0, 2, then 1, 1, 1, 2. We can't do that. We have to actually create variables that's going to get out the number for us, generate the number for us. So that's where this range function comes in. So the length of data right here is going to tell you how many inner lists there are. Remember that the length of a list is going to give you how many elements in the list. So if you said length of 5, 6, 7, it's going to give you 3. Well, Python looks at this big, huge data list and says, okay, I see 3 little lists inside it. So that means there must be 3 lists there. So this is going to generate numbers from 0 to 1 to 2. Remember, range stops at the end. So if you look, that's great because we want to go through row 0, row 1, and row 2. Like, we want all 3 of those numbers. That's why we call this row index. That's what we're going to use as our row. The second one is column index. Now, if we look at our column, well, first, let's take data row index. That's going to give you an inner list, right? So in our case, the first time this runs, it's going to give you del 10, 8, right? If you take the length of that, coincidentally, it's going to be 3, the same. But it's going to tell you how many pieces of data are in the inner list. So if I say length of this, what's that going to give me? 3. So we're going to use this to generate columns. Now, we don't want to get the first column, right? We don't want to try to int del. This is bad. So this is column 0. And we don't want to int del. So instead of starting at 0, 1, and 2, you can tell the range function, okay, I want to start at 1. So the range function will say, okay, just give me 1 and 2. So what you'll end up doing after both of these for loops are run is you're going to have 0, 1, 0, 0, 2,
6 and 2.
1, 1.
James, you're writing like J.
What?
You're 0, 2. 0 looks like a 6.
It is obviously a 0. 0, 2, 2. So after our for loop is done running, we'll have indexed at all 1, 2, 3, 4, 5, 6 positions. I didn't leave any out, right? That's all of them.
That's it.
Yeah. So if you were to look and index those values, data at row index, column index, that's going to give you each individual number here. So this one is 0, 1. This one is 0, 2. This one is 1, 1. This one is 1, 2. I'm going to click something. This one is 2, 1. This one is 2, 2. And if you look at your numbers, well, we have all those. So that's what that for loop does. That's what this is doing, is getting out that 10 string or getting out that 8 string. Does that make sense?
That's what that last line does.
Yeah, that's all that's the last line is doing. You could...
So what's that saying is like num is equal
Yeah.
to the values of all those?
Eventually, each iteration of the for loop, it's going to be one of them. So the first time it runs, it's going to be that 10, because that's the very first thing that you have. The next time it runs, it's going to be 8. Then the inner for loop's done, so it resets the first number. The first number is going to be 1. The inner for loop is going to be 1, so it's going to give you this 1, I think that was. Then it's going to go to 6. Then it's going to go to 2. Then it's going to go to 22. So that's also the same thing as saying you can actually get the row out first and index it separately. So this gives you your inner row first, and then you can actually get out the number of row at column index. You can split it up into 2 lines. Those do the exact same thing. So once we have our number, we want to convert it to an integer. So int num. It's pretty straightforward. Just use the int function. Now, because we can reassign stuff to lists because they are mutable, we're going to do the opposite thing we did in the first line. Right here. We're going to say data at row index, column index equals num. So the first time this runs, row index is going to... Oh, man. Row index is going to be 0. Column index is going to be 1. So let's look up in our list. Data at 0 is going to give you this inner list. This inner list at 1 is going to give you 10. So we get this num is equal to a string 10. That's what we get. You say, okay, let me int num. So let's change this from a string, and now it's going to be a straight 10 value. Then you say, okay, data at row index, which is still 0, at column index, which is still 1, is num. So you're basically saying, okay, I'm going to erase this thing here. I'm going to plug this in. Then you go to the next one, you do 8 the same way. And that's converting all those to all those inner strings to numbers. Yeah.
Okay, who did the XML problem I sent out? Yay!
Yes.
Yay, let's do that.
XML. Who likes XML? Anybody?
Have we done everything except for web parsing?
SQL.
SQL, GUIs,
Yeah, SQL, GUIs, you know, the rest of the class.
Those are like, yeah, I don't need to easiest things.
I hope so.
I kind of have trouble. Can you go over vocab after this?
Yes. Yes, that is a very good idea.
That is a great idea. This is a weird chair.
It's a stool. It's not
Show
even a
it the way
chair.
that.
Boom. All right.
Yeah. Okay.
So we did that one problem in recitation. This is a code writing problem because you guys have had an XML homework. That means there could be code writing. Uh-oh. All right. So somebody, let's start going over your solution. So I'd like to solve this together.
Oh, I know this question.
How do you know this question? I just made it up.
Read your mind.
It's because he's a pro. And so are you guys. Okay. Oh, you will be after this. Okay. So we've got this sample XML format right here. And so this is going to list products in various stores. So that's the whole point of this XML document, is to have a bunch of different stores and to tell us what products those stores sell, along with how much of each product they have and how much they cost. So what they want us to do is to go to this URL and get the XML file. Once we've got that, then we need to go through the XML file, retrieve each product name and the price of that item, make a tuple out of that, and append it to a list. And we do that for every product in this XML file. And then once we're done, we return that entire list. So, what are we going to do first?
You gotta import
Uh-huh.
URL and
So import.
URL, LIV,
Mhm.
request.
Yay, memorizing import statements.
Yep.
Import XML dot etree element tree as
As a side note, you don't have to add this as etree.
If you don't, you'll be writing out all of this every
So what
time
that
you want
does
to
is
use
remember
it.
when we say etree.parse? If you didn't have the as thing there, you would have to say xml.etree.elementtree.parse.
So you can name each trees and leave me one.
yeah.
Yeah, you could. It doesn't have to be etree. You could say as anything.
That's SQL stuff also.
I could do that too. That'd be perfectly valid.
You could say blah.url.
Yeah. All right, so we've got our two import statements down.
We gotta read in the website now.
We got to write a function header first.
Oh yeah.
All right, writing a function header.
Def get products empty print.
Done. All right, what next?
Response equals URL LIV request.
Ah, curses.
Haha. I'm not the only one.
Request URL our actual URL.
I can cheat. Okay.
Don't cheat when you're writing
Yes,
this on your
don't
exam.
cheat when you do the actual exam.
You will not get points.
What if we circle
this
the actual
squiggle.
URL on the top and just drew an arrow down all the way? You should give points for that. And then put quotes.
Don't try it. It depends on our mood. I don't know. If we get to your exam and everybody's failing, no, I would not count on getting points. Okay.
We said the URL equals squiggly. Never know what squiggly.
If your squiggle looks like http://site.com/finalxml, then you get credit. All right, so we've got our response. What are we doing now?
Tree equals
Tree equals tree.parse. Respone. Okay. All right, so now we have an XML tree made.
Squiggly stands for the URL, right?
Yes. Haha, okay.
I can't find the squiggly button on my keyboard.
Oh no. Yes, there's no squiggly button on my keyboard, and that's above your tab key. All right.
So basically, this is just code we have to memorize.
Right.
It's gonna be like the same no matter
Right.
what.
This stuff right here
There's
and this stuff right
several-
here is pretty much memorized.
Yeah.
There's several code types like that, opening files,
SQL import. And
SQL, import connection, or just stuff you got to memorize.
Yeah.
All right. So now we have the tree. What's the next thing we need to do?
Root equals
Get the root.
tree.getRoot inferences.
Mm-hmm.
You know, like if we don't want to get confused, can we name the root something else, right? 'Cause the
Yes.
Yeah.
name for this one is something else, so like stores or something.
Yes, you can name this
say
whatever you want.
Yeah.
That's another generic step to it.
Yes. So this one right here, all these three, yep, that's memorized code. All right. So now what we have is we have access to this stores element right here. And what that gives us access to is everything along this line.
That
Everything,
indentation level.
yes, everything that touches that line right there, you can get it right now.
And that's it.
Yep, that's all you can get. Now, what next?
Basically, root right now is store.
Stores.
Stores. Stores.find all. Or store equals store.find all.
Okay.
Root
Or
in your face.
root dot find all, and the name of it is a store.
Bingo. All right, now we have a list of store elements inside of stores. Now, what it's storing is an object. So the stuff in here, inside of stores, is a list of element objects. That data is not immediately useful to you. We need to actually go and get stuff out of it. But with stores, we need to go one level deeper. It's like XMLception. All right. Come on, no laughing at lame jokes. Ah, I'm disappointed. There we go.
I didn't see
Yeah.
that movie, so.
I didn't either, actually,
Oh,
which
what
makes
do
it
you
even
mean
funnier.
You haven't seen Inception?
Yeah. Okay.
It's all right, man.
Yeah. All right.
For product
Discriminating against
stores.
non-burglars.
Yeah.
Product.
Actually, that's probably not what we want to do.
You should probably say for store.
Uh-huh. Because this right here is not a product. It's a store.
Be very careful with your very full names and knowing where you're at.
Right. Because stores is a list of store elements, and now we're looping through each store. So right now, on the first iteration, we're looking at Awesome Shop. It's awesome because it sells apples and pears. Okay, so right now we're looking at Awesome Shop here. We have a store element. All right. Now, we don't care about the name of the store, so whatever.
Wait, I thought, but when you do find all of store,
Mm-hmm.
wouldn't it give you the store instead of store?
No, it did. That's why we named this variable store. I named this variable stores right here because it's a list of stores. But we'll rename that for clarity's sake. There we go.
List stores.
Oh no, I erased a parenthesis.
Do you want to draw the tree up top, or at least like maybe not all the data in it, but like
Yep.
the levels of the tree?
So the root is where the stores tag is.
Yes.
And then stores is where the store name tag is, right? Or the store.
I would
That's store, right?
highly suggest, if you're having trouble figuring out where you're at, draw the tree, whether we ask you to or not. Because knowing where you're at in the XML, that's the hardest part of getting data out.
See, the reason why I named it product was because, you know, when you have store equals
That top one should be S.
root.findAll, within that store, we can find the things within that thing, so I just named it product.
Right. I recommend that you name it what that particular element's tag is called. So that way you know exactly where you are. So in this particular case, we got shot 2.
So when you call find all, it's just going to give you a list of this level stuff.
Yeah, all the
So all the store.
Yeah.
When you loop through that list, you're still looping through these objects. So the first time, the first iteration of the for loop, it's going to point to this circle. You're not down here yet.
I don't really understand how these trees work in XML.
Okay, so this, the very first tag is called the root.
Yeah.
It starts at the top. It's just always at the top. Then you look one indentation level over.
Right.
So we have a store and a store here. Those are direct children of the root. What that means is they have this line connection to the root, and they have these circles here.
So like if we iterate through the store, it'll actually access us to the product, right?
If you iterate through the store, it will give you access to the product.
When you iterate through it, please use find already.
So once you get this indentation level, you say, okay, what's the next indentation level? So you kind kind of treat these as roots in a way. You say, okay, so if this is the root, what are its children? So each store tag has a product child. So a store tag has 2 product childs. Then you go to the next one and say, okay, I'm looking at the product tag, what are its childs? Well, it's got a quantity and a cost. So 2 bubbles and lines go down from product.
Our root is already stores, right?
Yes, and this is your root up top. This is the whole tree. Generally, the way you want to think about this is once you get here, this is a new subtree. So you're basically at the top of the subtree. I want to go to the children. So you go down here, this is the top of its tree, its subtree. So say, okay, I want to go down here. Oh, if I'm at the data I want, get it, or whatever you need. I don't think you need quantity in this case.
So we're not worried about an XML file, it's like figured in this pretty much?
What we'll generally say is something like, okay, here's an XML file, here's the format. But there could be more data.
Okay.
So, maybe there's, 4 stores as opposed to just 2. We'll give you a decent amount of example, but it may not be the whole thing.
Right. Additionally, we do things the way we do using find all and all of that stuff instead of just looping through every element in one of these subtrees, because there's a possibility that instead of just having stores at this indentation level, or store elements, we could also have something like a region element or something like that down there somewhere for some odd and stupid reason, because that's how XML works. So it's safer to use find all to get the elements you want, or find to get the elements you want, instead of just looping through every element in the tree, because if you use find and find all, you're guaranteed to only get the elements you want. Whereas if you just do a straight loop through every child element of a particular tag, you could get a tag you don't want.
Do we need to worry about LXML? Because those on the dive into Python that you guys said.
LXML?
Yeah.
No.
Okay. I was reading that, I was like, why are we?
The answer is no. And why is it in there?
I don't know. This quantity is...
So we had a question in recitation where you had to draw the tree, but if you have time, I would always suggest doing it anyways. Because it's a lot easier to figure out what code to write when you know where you're at, and you can visualize it and see it.
Which level you're down at.
Yeah. And so what I would do is you have a root here, so right, root pointed to here. And then when you're making variable names, so like in our case down there where we said for store and list of stores, you could put like a store variable pointing to here, so you know exactly where you're at.
But if we did find all with the store already, it already goes to the
Use
next
find all
one.
for the
So
first time?
what'll happen when you use find all, it won't go to the next one. All it's gonna do is give you a list of these. Unless you loop through that list and, go to each individual one, it's not gonna do that for you. It's just gonna say, you say find all store, it's gonna say, hey, we have, 10 store objects, and that's all it's gonna say. It's not actually gonna do anything on it. You have to do that.
All right. So we have this, and now we're looking at an individual store. Okay. Now, each store is going to have a bunch of products, so we need to repeat the same process that we just did again. So we're going to say, all right, as soon as I select my pen again, list products is equal to store, because products are located under stores. So we have to say store.findAll, and we are looking for a product tag. Is it capitalized? No.
I don't think anything's capitalized.
Nope. PR. No, we don't want to use find here because there's more than one product. If there's only one of a particular tag, use find. If there's a bunch of those tags that you need, use find all. We're going to use find in a moment, but we don't want to use it here. All right, so now list products is going to be a bunch of products. So now we need to look at each particular product. Now, I have neglected to put something here that will come back and cause us grief when we get to this point in our code writing. What did I forget? An empty list. Yes. Silly me. All right, so somewhere right in here, there's going to be,
Before the loop.
yes, somewhere before this outer for loop, we've got, I'm going to say result is equal to
So it's above
empty list.
stores.
Yes, it could
It
be.
doesn't really matter
As long as it's
as
above the
long
Yes.
as it's above the for loop.
All right. So now list products is going to be our list of products that we need to iterate through. So now we're going to have another for loop. Yet another good case to use nested loops. For product in list products.
So just because you're finding it doesn't mean you're down to the next level yet. You have
Right.
to iterate.
The
Yes.
for loop is going to the next
Oh,
level.
and then the reason why we do find or find all is to show that there's only one of those tags or one of those elements or more than one. Right?
Yeah. All right, so we have for product and list product. So now product is going to be one individual product tag. Now we are at the level where we can access all of the data that we need. Specifically, the data we need is the product name plus its cost. So if we look at our tree, we are now located there. All right. So you notice that we can get access to this name right there and also this cost because it's one element under it. And according to the description, we told you each product is only going to have one quantity and cost tag in it. So because we told you that, we know we can use find.
It is also guaranteed to have both of them.
Yes.
So there's not going to be a case where it doesn't have
All right.
one there.
You are guaranteed, according to the XML description right up here in this little paragraph, you are guaranteed to have a quantity and cost tag in it.
And only one.
Yes, and only
of
one.
each.
Okay. So if you're certain of a number, then you just use the dot line. If you're not certain,
If you're certain that there is only one, use find. If there's more than one, or possibly more than one, use find all. So, now what we do is we're going to say, okay, I need to find the cost. So cost is equal to product dot find. We're looking for cost. All right, so now this cost variable over here is going to be our element right here that contains the cost. So now what we need to do is construct our tuple.
quantity first.
Don't you need?
Well, actually, according to the instructions, we don't need to do anything with quantity.
Wait, what happens if you do cost equals product dot find cost?
So if we do cost equals product.find cost, let's say we're looking at the product apples right here. What it's going to do is it's going to say there's going to be some variable called cost, and it points to that element right there.
And then later on, when we're trying to construct our tuple, we can do cost dot text.
Yes, that's exactly what we're going to do right now, actually.
Do you need to float
Oh,
it?
no.
Don't you
Curses.
need to float it first?
Yes, we do.
Or you can do that on a separate line.
We can if we want to.
There's a lot of steps.
Yes, there are.
Yes.
This is specifically why we gave you an XML tree that was this small and this simple, because if it was any more complicated than this, let's say like the IBM one that we gave you for homework 10,
And you get like a
you'd be
million.
writing a lot of code. So,
This is probably going to be about as complex of an XML file as we're going to get.
right. So,
But all these steps are kind of the same for all of them, right? Like
pretty much.
Yeah, like with the first 4 or 5 lines, and then after that, it would just be like iterating through each level to get to the next
Yeah.
Mm-hmm.
And when we find something that's dot find, we don't have to iterate through inside that. Huh?
Right, because it's only one element. You wouldn't need to, a loop is used for doing multiple things multiple times.
Gotcha.
All right. So, what I just did was I just got the actual value of the cost out of the cost element. So remember that cost is our cost element. It's an object. We can't just straight up float that. It's not valid. So what I had to do was I got cost.text out. Remember that all stuff that you're getting out of an XML file is a string. Everything. Even if it's supposed to be a number, it's always a string. You have to make it into a numeric type if you are required to do that. In this particular case, we told you you had to make the cost into a float. So that's why I floated it right there. So boom.
Is
Yay.
it TEXT or TXT?
It's TEXT. All right. So now we have the cost. We need to get the product name. So
The attributes.
I'm going to say name is equal to, yes, that's exactly right. It is an attribute, and it is an attribute of what tag? Product. Yep. Product.attrib. .attrib is a dictionary. We access that just like a dictionary. What are we putting inside the square brackets? The key,
Name.
which is name. Bam.
What's attrib again?
Attrib is your list of attributes in this XML document. So, the attributes for this particular tag right here is going to be the name right here. This right there. That's an attribute.
Would the cost be an attribute too?
The cost is a sub-element.
You know how attributes are dictionaries, and then the ones that we're putting in here in the square brackets are the keys,
Mm-hmm.
and keys can be integers also. So if like 8 equals something as our tag, will we still have strings around it since it's an XML file?
I don't think you can have an attribute name that's not a string.
Okay.
I don't think that's valid XML.
Yeah, I think it's against the rules of XML to do that. But your attribute, your key, is that right there. So this is the key.
Yeah, so XML basically can store 3 main types of data. The 2 you're really concerned about is attributes. That's the ones inside tags.
Text.
So anything in between these brackets, this is an attribute. The other thing in between the brackets that's useful is the tag name. You probably won't ever need to use that in your code other than looping through it or finding them. There is you could say product.tag and it will give you a product stream if you need it. These come out as project.attrib. The other piece of data type are the ones in between
Text.
tags. These are called text, and it's just one string, whereas these are attributes.
Okay. So we now have our numerical cost and our name. Now all we need to do is construct the tuple and put it in the list. So we're going to say, first select our pen tool so we don't erase everything. And the list that we're trying to append this new tuple into is result. So I'm just going to say result dot append. And inside the parentheses, I'm going to construct this new tuple. And the first thing is going to be the name. And the second thing is going to be the cost value. Now you could create that tuple on another line and then just put that variable name inside result.append, but that's a fairly simple operation, so I just put it on one line.
You actually do all 4 of those lines on one line.
Yeah, you could, but that would be really ugly. Okay, so that's all the stuff we need to do inside of our for loops.
Did you have a question?
Yeah. So you know how it went from for store and list stores, and then we found a list products.
Mm-hmm.
Why is it for product in list products and not product in store?
Okay, the reason in this particular XML file, according to the sample file we gave you, it would be valid either way you do it.
Okay.
Now, that's not necessarily true for all XML. For example, this could have something different in it. Let's say under the store tag, I could also have another tag called address or something like that down here at the bottom or somewhere in it. And if we did for product in store, what it would do is it would go through and it would give us every single sub-element under store.
So the first two would be products, which is good, but the last one would be address, would be an address tag, and you're trying to do these dot finds on an address tag that probably won't have cost and quantities, and most likely it's not going to do what you want it to do.
Yeah, that will break. That's why we use find and find all, is to explicitly say I only want these tags, so it doesn't break like that anymore.
So it's kind of like we're finding particular sub-element within the element.
Yes.
Yeah. If you look at list products, that is a store.find all. So you are inside store. You're just saying, hey, don't give me all your children, just give me the ones that, say product.
Hey, return result. We're done. Yay.
So a couple things for this. Anytime you have multiple tags with the same name, so the product tag, usually you're going to use a find all and a loop. If there's one, you generally use a dot find, no dot attrib, no dot text. The final key thing really is that you can't walk back up the tree. So if there was something in the store tag that you needed, maybe the store name, you need to save it before you go down.
Oh, could I ask about
So,
writing XML where like we do element and sub-element and stuff? Do you have to worry about that?
I would say not as code writing
yeah, not as code writing, but you could see it as code reading.
or multiple
Multiple
choice
choice.
kind of thing.
What are you about to say about
So-
store values?
Imagine that, for example, under this store tag, let's say we had another tag in there that was address or whatever under store, and we needed to put the address of the store plus the product name plus the cost. So the first thing we'd have to find is the address, and then we'd have to find the product name and cost. And we can't just magically access that address tag from inside of this inner for loop right here.
Right. That inner for loop. Actually, no.
You can't.
No. Where you have
So,
it.
like, if you had to store the
So,
address, where would you?
Scroll up to the where you're at on the tree. It depends on where your stuff is stored. So that inner for loop, you're on this level right here. Right? This is where product is. If you had, instead of just two products, maybe store had another one that's like address, you would need to store the address if the question asked for it.
Okay, so.
So
It was under store, then before you went to the second form, that said for product and list products, you would have to say list products equals dot find all, and then like address equals dot find
Yeah.
all address.
I would say assume there'd be only one address for a store.
It's a dot find address.
So somewhere in here,
Yeah.
or
Before
before
you-
the find all if you want to. I'll put it before so it kind of makes more sense. Somewhere in here, you would do store dot find address,
And set it equal to something.
and then this is the
Right.
address.
And then set it equal to something. So long as you have access to the element object itself, you can get the data out of it.
Address.
So then your result out of pen would just be a result out of pen, name, address, cost value.
Right.
And by dot tag, that's not what I meant to say.
Not text.
Address tag dot text. So when you're in the inner for loop, this address exists. Like it's a variable that you can access.
Yeah.
So you see result dot append name or address name cost value, something like that.
All right, that's pretty much all there is for XML code writing. I don't think you're going to see anything other than that. I thought about preparing another example that would have been really, really hard, and then I neglected to do that because it was really, really hard.
You have to explain it.
Well, the idea was I was going to give you some Python code and then what it output and tell you to write the XML that it came from.
Oh
Yeah, yeah.
no!
And then I decided that would be a little bit mean, so I didn't do that.
What's up?
Do we have to close XML trees?
What you would.
If you had to open a file to read in an XML tree from a file, then you would need to close the file. But you don't have to do anything special like closing the tree or anything like that.
Do you have to close the internet connection? Does that do it default?
Yeah, it gets it and then disconnects.
Oh, it does?
Yeah.
Like a boss.
Yeah. Yes.
Can you actually have a working continuous file so that we can practice?
Like this particular one? Or
Yeah, this one or just read it up and something else.
Yeah,
do
I can
you-
put one
do
up
you
on
have
my
a
server. Yeah, I'll put one up on my server and send out an email. Okay. Vocab.
Deep copy. What is it? I'm just kidding. That was a joke.
That was a test question on last semester's test. One of the answer choices was deep copy, and nobody knew what that was. And once again, that's because we didn't tell you what it was, and therefore it's a wrong answer. Seriously, if you learn nothing else before you take the multiple choice questions, if you've never heard of it, it's probably wrong.
Well, we've heard of so many things, we don't know if we've never heard of it or heard of it once.
Yeah, like polymorphism, I think I heard that in
Like, I
2602.
feel like I heard it, but yet I didn't hear it, so I might confuse it.
Wait, you've heard of polymorphism in 2602?
I don't know, but like, I've heard it before.
I feel like I heard something
Like, I've heard of it before.
What?
What?
I think in 1931 I've heard of polymorphism before.
No, well, you don't count.
You don't count.
I mean, I've
You
heard
took
of that, like,
1331.
It's only CS major like this.
All right, vocabulary. All right, I'm going to start with XML because that's what's on my mind. We have,
Yeah, I think I heard of that in graph theory. 2602. Well, that's isomorphism.
Yeah,
That's
yeah.
element,
But it reminded me.
Sub-element. Are you going to define node?
root,
I don't know what else you'd call it.
Now this is vocabulary just for XML.
Sub-element.
right. I'm going to go over the rest of the vocab in just a minute.
Child? Would that be
Um,
under sub-element?
Yeah, that's here.
And then, what about parent?
I don't think they need to know what parent is.
All right.
We don't have anything to do with like inheritance. That's not on this test.
No,
No.
there will not be any inheritance. We took that out of the
Like
class.
super and all that
Mm-mm.
stuff.
No supers?
Yeah,
No, did we even do polymorphism?
No.
Did we teach that?
no,
No.
no.
We should have.
Root, there's
We talked enough.
attribute,
Well, yeah.
tag. Anything else?
Do you want to go over like generic tree kind of things? Like a tree?
Nah.
No. Okay. A branch, a leaf. Subtrees.
Can we?
Forests.
Forest, yeah!
Let's not get too technical.
All right, so that's your XML definitions. Now, with the exception of maybe some multiple choice questions, there's not going to be, as far as I know, a vocabulary section on the test. But you need to know what these words are to be able to answer questions correctly.
In multiple choice.
Yes.
Especially.
Yes, that's very important. If you don't know what they mean, it's going to screw you up because we use very specific wording. So, an element / node, what is that?
I don't know.
I'm afraid that is not the correct answer.
You do not win $1 million.
Okay, so an element or a node is, what's a good way to describe this?
Child of the root.
Not necessarily.
Any
It's a container object.
I can Google. I guess object would be the best way to describe it. Tag
So like
name.
in our example, the element would be stores.
An element would actually be,
Any of those circles on that tree we drew, those are all
Right.
elements.
so the circles are elements. Now, a sub-element or child is an element which is contained in or contained by another element.
So, the child and sub-element are the ones directly connected or contained by. So, store is a child or sub-element of stores. Product is a child or sub-element of store.
They are all elements.
A child or sub-element of stores.
So element isn't
Like it doesn't jump up too
No.
much,
Right.
right?
That's,
Yeah.
yeah, that's correct. It does not jump up. So product is not a sub-element of stores directly.
You have to have
Indirectly,
this
it is.
line.
Right.
This line
So-
designates.
so elements are sub-element of a root because store
Yes.
is right now.
Right.
Indirectly.
Yes, indirectly.
Some of them are directly sub-elements of the root. These are indirectly.
Oh, because anything is named the element, right?
Yeah,
Right.
all of these circles
That's
are
what
elements.
So for example, if we were to say quantity is a direct sub-element of stores or is a direct child of stores, is that true or false? False.
Correct.
Can you use the word direct though on your exam?
Yes, we
Yes,
would be
we will
specific.
use the word direct.
We will be specific.
And if it doesn't say, you can probably ask one of us because it should say.
Roots, there are roots elements.
Yes.
Yes.
It's like one element that's on the top.
Root is the very top element.
And there's only one of them.
And there's only one in a tree.
There could be multiple roots.
No, you need
No.
one root.
There's one root in a tree.
One root.
Now in a forest, it's different.
Was that a joke?
No.
That's something from combinatorics.
Or 1332.
Or 1332. Did we go over forest and 13? Ah, whatever.
Kinda.
All right, so a root is the topmost element in a tree, not
Group of trees
a
connected together.
sub-element. All right, that is not a sub-element. It is the only element in the tree that is not a sub-element. Okay, that is how you define the root.
Vocab.
Attribute.
How would you describe that? Like the things in the tag that
Mhm.
describe a tag with values in the.
Basically, it's like value that's in the tag, or it's data
I
that's
would say
yeah, it's
data
data.
in the tag that has a name and a value or something. You can have more than one attribute.
Separated by space.
Mhm.
Yeah, they'll be separated by spaces. A lot of the examples we've been giving you only have one attribute. That's not necessarily the case. You can have as many attributes as you want. If you remember the IBM XML data, the PLC info had like 10 of them.
Now, unless it helps you memorize this stuff, you don't have to write this down because I'm going to publish this PDF. But
Yeah.
it might help you to write it down just to
Actually,
to memorize it. But if you miss a word because I keep going on, don't worry about it. You can get it later.
Hopefully it'll be on a video. If not, this will be on.
Well, this is a very long video.
Yeah, this is
It's a-
Almost 4 hours.
yeah, it's pushing. Yeah, it's
Actually, I
pushing
think
pretty
we're
long.
about to the end. I think there's a cap on how long you can record.
What if it caps?
No.
Like I want to say, if you look at the recording, it's like 50 minutes left or something.
No. I think it's 5 hours.
Oh, is it 5 hours? Maybe we got an hour and a half.
All right. So, attributes here. This is an attribute. All right, that's an attribute. This whole thing right here, that's crossing that out. All right, this whole thing right here is the opening tag. Why are you doing this? All right, that's the open tag, and then the associated closed tag is this guy right here.
And the stores called again? The root?
It's the root.
The root.
So this is a root. There we go.
All right, and the name pairs is key.
Hmm?
The name pairs is the key.
So name right here inside of this attribute, the key for this attribute pair, man, that was close. The name for this attribute pair is the key in that attribute pair, and the value is pairs.
Okay, key is name, value is pairs.
Yes. And then this right here is the value. Okay. So the tag. Now, this is kind of a word that has two different meanings depending on what context it's used in. So, the first thing it can refer to is it can refer to the actual name of this element.
It's kind of a short for the tag name.
Right. So, in this case, the root's tag would be what? Stores. Yes. The other meaning is all of that right there, that entire line. The store name equals shop to line. So that also includes attributes. It's the left angle bracket, the tag name, space, any attributes, and then right angle bracket. That's a tag. So
Specifically, that's an opening tag.
So any sub-elements could be a tag too, huh?
So-
every element is a tag.
And sub-elements are elements. It's just
Yes.
Yes.
All right, and so the text is data that's contained between an open and closed tag. Brandon was right. After 2110, you will learn how to draw an ampersand. Okay,
Stupid.
scroll up.
Data one more time? I just want to like what A is. Okay.
Okay,
Why do we have a list of 32,000 most common words?
what?
Why do we have a list of 32,000 common words on our website?
I
At the
think
bottom?
you have
Professor Summit did a demo with that.
Okay. All right, so other vocab. We have the lovely instance variable. I can't spell instance. Oh, man. A-N-C-E.
Instance, class, and local. Do we need to do global as well?
Might as well. Because globally was
I would
on the
actually
last
do
test.
it. I would do it from top down. So I'd write class,
Arrgh.
global, class, instance, local.
You should say these things before I write
Why didn't
them.
think about it? Before that.
So let me do global scope. Okay, global scope. Class scope. Instance scope.
This is probably one of the more complicated topics about objects that we might ask questions about, at least as far as instance variables and instance scope is concerned.
Indirectly. This is the
Indirectly.
official name for it. So an instance variable has instance scope. Now what that means is that it's accessible to that particular instance of a class and that instance only. So instance scope is typically used with instance variables. in the sense that when we declare a variable as, let's say, self or whatever, that it's only good for that particular instance. So if we have two objects, then its self variables are different than the other object's self variables. That means they have instance scope. They're only good for each particular instance of the class.
By scope, we're talking about which part of our program can access this or use it.
Okay, so global scope means...
Global variable?
Hmm?
You don't want global variable?
Ah, crap. That's not intentional, but I'm not rewriting all that.
Okay. I was just double checking.
Okay. Global scope means accessible anywhere.
Within the file. Or within the Python file, right?
Within your current execution domain. So basically, for what we do, that's a file, yes. Okay, that means it's accessible anywhere. Class scope. Accessible anywhere in class. So when we define a class, it's a variable that's indented one level under the class, but not inside of a function. That's class scope. So for example, functions that are declared inside of a class can only be used when you're referring to that particular class. Instance scope.
You can't call the function by itself. You have to call
Well,
the class first. You have to make an object. Make an instance.
yes, that's right.
Okay.
So instance scope, accessible inside an individual.
When we say an
Object.
instance of a class and an object, they're basically the same thing.
Instance of a class. Local scope, accessible inside function only. So, any variables that you declare inside of a function have local scope. The minute that function is done, it goes away. Earlier, when we talked about importing inside of a function, so like we had def, whatever the name of that function was, and then we did import string inside of that, that import has local scope. So it's not just variables that have scope. Your imports can also have scope. All that other kind of stuff also has scope.
Functions.
Yes, functions have scope. A function inside of a function, that inner function has local scope. It's only valid, you can only call it from inside that other function, nowhere else. Now, class variables, they are shared between all instances.
So, if one instance changes the class variable, it changes for all of them. That's what it means by it's shared.
Okay, an instance variable. I need to write a better way of writing that.
Individual to the instance.
Yes. Each instance has its own copy. This means that for any method inside of the class, if it chooses to access that instance variable, the value is the same until that object is no longer valid. So if we have those two objects that we talked about earlier, if we change the instance variable in one, it does not change the value in the other object. They're completely separate. Right, a local variable declared inside a block.
Used only.
That's a for loop, while loop, function.
Actually, that's not quite true. The garbage collector won't take it out until the function's done.
Ah, damn it. Why you gotta be silly?
Well, I'm just telling you what Python.
Yeah, okay.
It's kind of useful sometimes.
Declared inside a function. All right, so this local variable only exists inside that function. When the function is done, boom, that's it, it's gone. No more using it. So, parameters in functions have what scope? Yes, they are local scope.
What if they were like methods though? Like the stuff within the methods?
What do you mean?
Then they'd be instance, right?
Well, okay, so methods are functions. Remember that. They're just kind of special.
So if we were to name something self dot whatever within the method, then that would be an instance.
Instance variable.
Yes.
Yes.
And if we just said like a equals 2 or something, that would be a local variable.
Yes.
Okay.
Right. So if we put self dot in front of something, or whatever the name of the instance modifier is, if we put that, like self dot, in front of a variable name, it automatically kicks it up to instance scope.
Do you want to?
All right, and global variable,
Used everywhere.
yes.
Has global scope.
Yeah, variable with global scope. That's really, it's a globally accessible variable. You can use it anywhere. That's pretty much all there is to
Anyone know
it.
how to make a global variable?
You say global, and
Mm-hmm.
then whatever it is.
Well, would you say global, like, before everything then?
There's a couple ways you can do it. You can, the way I usually do it is inside the function. If you want to use a variable declared outside the function, say global that variable.
What if you do global outside the function?
That's a good question. What if you do global outside the function?
Not valid. Don't do it.
Oh, you
I've
can't,
never done that, so.
you can't use global outside functions?
No. So the global keyword is to tell Python, this variable that I'm talking about, I want you to refer to the global scope of that variable, not local scope. So for example, if we have a function, or actually let me write the variable here. So I'm going to say x is equal to 6.
Global before you made the rest of the function below it.
What do you mean?
I thought that you could say a global, like, a variable name, and then you may all the functions below it that refer to that global.
They can, but if we do something like this, if, you know, the first time we talk about this variable right here, let's say we want to say x is equal to 7 right there. What happened is Python right here just made a brand new x with local scope.
And
Okay.
then dropped it when that function was done.
Right, and then it dropped it. So now after this function is finished executing, if we called func,
Write the function call first.
right, so then we say func.
Remember that the function is only called when you have this line.
All right, so if we ran that, it's going to print 6. The reason why is when we did this assignment right here, Python didn't know we wanted to refer to the x in global scope. It thought we wanted to create a new x in local scope. So the way we get around that is by editing this slightly and saying global x. And so that tells Python for every reference to the variable x inside of this function, do not create a new x. I want you to refer to the x that's declared here. So then we say x is equal to 7, and now it will print 7 instead of 6. Yes?
Can we do that to declare global variables that have not been initialized yet, or will that give us a,
Probably give an error.
I don't know. Let's find out.
preference before?
Well, I don't know. That's a good question.
Cool.
Nothing?
Oh, no, we already had an X. Gosh darn it.
Delete X.
Yeah. Good. All right. Yeah, that works.
Oh, you need to move it over so people can
Oh.
see. It's returning 7. Or printing 7.
So yes, that is valid. If the
if
variable
it doesn't exist,
yeah.
it'll create a global scope variable for
Right.
you.
Can you do the same thing with imports?
Maybe? I don't know.
So
We're not going to ask you to do that on a test, though.
Since we had the global within the function, if we had another function that called for x, it would actually have x now, right?
Yes.
Okay.
Assuming you told it global X at the front of that function too.
Oh, okay. So it feels like definition function 2, you would have to put global x again.
If you wanted it to access the global X, you'd have to put it again.
Oh. Plus x.
Yeah, there we go. So
So if you were to do, instead of x equals 8, if you were to do x equals 8 plus x, it would have been 15?
Yes.
Because
Yes.
it's accessing previous x.
mhm. If I did not put global right there, it would have said X is equal to 7.
Oh,
Actually, it
was
would've
already
broke.
global with the 7, but we just didn't call it within this function.
Right.
Okay.
The addition method would have broke, actually.
Yeah, actually, yeah, it would have. Okay, so that's global. All right, actually,
Does everyone understand instance and class scope?
So like class.
crap.
All right, so let's draw the.
Crap.
Oh, you're trying to put that somewhere.
Yeah, I'm trying to move this somewhere else.
It's pretty cool.
All right.
So, I don't know where to draw this. A class, we've told you, is like a blueprint. So somewhere we have this class file student. And in here, we have maybe the school.
Oh yeah, I remember that.
Or better, probably more, makes more sense, state or something. GA. And then you have definite. Right? So that, because it's right here, is a global, or is a class scope. When you make a student object, so S equals student, you know, maybe it has a self dot name here, and dang it, that's an instance variable. And usually you draw some kind of line. If you had another student here, S2 equals student. Let's choose this real quickly. Self dot name Joe. If you were to do S dot, if you do S dot state, does it change it to a instance variable?
If you just S dot state, or wait, what is S?
Student. It's a student object.
S dot state is an instance variable.
Even if we didn't make it originally.
I think attempting to change any instance variable like that will cause it to create an instance variable.
So you have to do student dot state.
Yes.
Okay. So if you did student dot state equals there you go. It would change the state, or the state for every student. So S dot state is going to give you AL. S2 dot state is going to give you AL. Even though you only did this one line of code right here. Because you're basically, when you do this, changing a class variable, you're changing the blueprint up here. So in the instance or the object reads the blueprint, it sees the change, and that's what it uses.
So what would student mean? Student is just a class, I guess. You can't really.
So class student is a class. These are objects.
And then the things within inside the objects are object variables.
Object or instance variables. I'll also put instance here.
And then the ones within the class, like state equals short, is class.
That's
variable.
class. Yeah. Class. Variable.
Okay.
Usually you access it with the class name right here, dot the variable name. Whereas instance variables, you use this s, s dot name.
Yeah, okay, got it.
Okay, so, yeah.
Okay, there's also the different types of loops. So there's,
For loops.
mainly the difference is if we refer to something for each and for. All right, that's a little bit different. For each is something like for item.
You realize every for
In-
loop in Python is a for each loop.
Yeah, damn it. You're right. It uses a generator.
Huh?
All right, basically every type of loop is a for each loop, so never mind, you don't need to know that.
What happens is so a for each loop generally gets the piece of data out of a compound data structure. So, for item in list, item's going to be the value of that list. We can get around that because we have a built-in method called range. Range generates a list. Like it's going to give you a list. So even though you're saying for index in range something, you're still saying for index in list. So they're all for each loops.
Quick question.
Yeah.
The self dot name
Yes.
and stuff with the self is an object variable because it doesn't get created until we create that object, right?
Yes.
Even if it's within that class.
Yes. And each object has their own version.
Yeah.
So they can change their self.name and it doesn't affect anyone else.
There we go. Okay. Yeah. But if we were to say self dot name equals something, like configuring it that way, then it would change for both of them.
You would have, if you wanted it to change for everyone, you would either have to have the name variable be up top before the init method,
Yeah.
and you would have to refer to it as student.name. By referring to it as student.name, it's a class variable, and it'll affect all instances of student.
Like what I'm saying is, let's say we had a label, okay?
Okay?
That's self dot label equals label.
Mhm.
And the text says food or whatever, right? And then we made an object name which is called OB, right? And then we did OB dot label dot config. That changes only the object, right?
Yeah, it would change
And then
only that.
If we made OB2, it wouldn't change that one.
Correct.
However, if we were to change something like self dot label dot config, would that change the whole thing?
You're only going to say self.label.config inside the class definition.
Okay.
So
it won't really like.
it wouldn't change both of them. You would literally have to have something like GUI.label if the GUI is the name of your class.
Mhm.
Then if you changed GUI.label, it would change it for both of them.
Okay, alright.
That's the only way to really change it for both of them.
Will's been quietly writing.
Yeah.
All right, who wants to give me a definition of a widget?
Widgets.
I'll take a stab at it.
Go for it.
An object within a GUI class that can have its variables changed after a method is run.
Kind of close, but we can go a little bit more general than that.
Yes, that is true. But you can go more general.
hmm So, generally speaking, it is any, I guess we could say,
Any container, object, I don't know what else you call them.
All right, so widgets are things like your entry boxes, labels, buttons, frames, anything of that nature.
Radio buttons.
Yes, radio buttons. That's a good one.
All those are called widgets. I wonder who came up with the name widget.
Window decorations. All right, this one is easier to draw a picture. This is your window.
Pictures. This is assuming you are on a Windows. The Mac window decorations will look different. And we don't care which one you draw.
There you go. That's
If
the
we
window
change
decorations.
The title, we would do like, if it was named root.title, right? And then-
Yes. All right, so that's the window decorations. Oh, here's a lot
Okay,
of
so
stuff.
does
What
it
about
do when we
immutable,
create a
immutable?
radio
Yeah.
button without an int var?
Say that again?
What does it do when we create a radio button without an int var?
Bad things.
Don't ever do it.
Yeah, don't ever do that. Basically, it makes your radio buttons unable to be used.
Okay.
I mean, you can still click on them, but you'll be able to click on all of them, and it will select all of them. No. You will never be able to tell which one of them is selected, and you will never only be able to select one of them.
You could select multiple.
Yeah.
If you really wanted that, there's another widget I think called like checkbox.
Let's see.
So,
A lot of information.
It's gonna confuse me.
I'm sorry, that was a side note. Don't.
Mutable. Yes.
Why does that clock not work? Why do we have no working clocks?
I don't know.
Oh, what
Yeah.
are like, so, you said like immutable compounds,
Compounds when you have more than one data.
so like list.
Lists, dictionaries are compound, tuples are compound. Did we ever end up saying that strings
Are compound.
Strings are compound.
You know what's weird? You know how you guys said you can't change a tuple?
Yes.
But when you do like tuple 2, 2,3 plus tuple 2,3, you get 2, 3, 2, 3.
Yeah, you do. It's returning a new tuple to you. If you have variables like A and B that are those two initial tuples, and then you do A plus B, it doesn't change A or B. If you print out A or B, they're the same thing.
And then a tuple with just a single element isn't a tuple, is it? Because I tried doing parentheses.
No, it.
You have
it
to do-
is. You have to do
yep.
a parenthesis value comma
Yeah.
close parentheses, or alternatively, you can just say value comma, and it will be a tuple.
Oh, without like any parentheses?
I believe that
Oh,
will.
yeah, you're right. But if you just had parentheses without the comma.
If you have a parenthesis without the comma and there's only one thing in there, Python won't make a tuple for some reason. There has to be two for it to make a tuple, or you have to put a comma in there to say, "Hey Python, I want a tuple." Do it. And the reason we consider strings as compound data types is because you can think of them almost as a list of characters, with the exception that they can't be changed. So you can index into them, or you can slice them. Things that compound data types you can do with.
All right, so primitive data types. Anybody want to give me a definition for this one?
Just single.
Yeah, single pieces of data.
Not strings.
Hmm?
Not strings. What is that?
Yeah, not a string.
It can still be sliced, right? We just gotta make
No,
sure it's sliced one.
no,
What's it?
no.
You
cannot
cannot slice
no.
primitives.
No, don't do
Oh yeah,
that.
you can't do
At
like
all.
Index of 0. I guess.
No.
Bad.
Okay.
I can't think any off the top of my head.
I think that's pretty much it, right?
No, hang on.
Well, but okay.
Yeah. Yeah. That's, do we
specific.
Yeah, they're for strings. No, not strings. Integer. Well,
Who's ready?
Container widget contains other widgets.
That's, yeah, it's pretty
A
much
frame,
exactly, yeah. A
Or
frame.
the root window that you make. Those are container widgets.
Yep. Let's see. Oh, yeah. Oh, yeah.
star.
Yeah, no.
Bad.
No.
Never,
No.
ever, ever.
How can you delete the target?
Drop table.
You can do
Alternatively,
truncate,
truncate
yeah,
table,
truncate table, or just delete star
from
from,
table.
yeah, delete.
Not
oh,
delete
no! No, I said it. Oh, no, I need to go wash my mouth out with soap now. Oh, man.
There's 3 ways to do it. If you just want to take everything off the table, it's delete from table. Takes everything out. You can do truncate table. That does a little bit of extra stuff. I can't tell you what it does. Will probably could. Or if
Nope.
you just want to take the table out of the database, you can say drop table.
The table is gone.
Now, I don't think your login information is able to drop table. I'm pretty
No,
sure
it
you
can't.
don't have permissions to do that.
Okay.
But
Can I see the container widget definition one more?
Yep.
Contains
I'm sorry, but I can't get any more specific than that. That's what it does.
it's just frames and the root window.
Sorry for these recursive definitions, but really there's no other way of describing some of them.
I mean, the frame doesn't really do. I mean, you can make it change the border, make it raised or make it sunken or something, but it doesn't really do anything.
So for a recursive function, or for it to be proper recursion, what things do you need?
Terminating condition.
And?
Recursive call,
Yes.
Yes?
base case.
Okay, that's a terminating condition.
Terminating condition.
Terminating.
And there's one more.
Oh, it needs to approach the base case.
Bingo.
Yes.
Those are the 3 things. All right, so recursion steps. 1.
If you don't go towards the terminating condition, it will recurse forever. and
Terminating
ever.
condition. 2.
It's like an infinite loop
It'll go on as long as the memory has
until
space.
you run out of memory,
Push that
and
one
then it
button,
yells
no,
at you.
3.
And it will run out of memory quickly.
Bam. All right. That's a good multiple choice question right there. I think I actually asked that on
Can you put this
Fall's
in the
final.
test?
I don't know.
On this one?
Maybe.
Think about it.
Yeah, we'll think about it.
You guys didn't make the final yet? Oh, I thought y'all already made
Just like everything else we do in this class, we'll do it about the hour before your final. I'm just kidding. No, it'll be.
I wrote my questions already, or some
yeah,
of them.
I'm the bad TA. I haven't written mine yet. Yes.
I kind of have trouble with GUIs. When we're given the code, I have trouble drawing them. So can we just like go over that?
Sure. Well, unfortunately, I don't have a good example of that ready.
Well, all right.
Yeah, pretty
Yeah,
much.
if y'all are done.
Yeah.
Or if y'all don't have any more
I mean,
questions.
yeah, if you don't have any more questions, we're free to go. But if you do, stick
I
around.
mean, you were free to go the whole time. We're not making you be here.
Other people left. They don't love us as much.
it. Actually, it is really helpful.
Uh-oh.
Yes.
We're running out of time.
Review session tomorrow.
Did I screw something up again?
Review session tomorrow.
All right.
Review session tomorrow.
All right. So specifically,
I'll do that tonight
like,
when I'm grading.
Can I? I'll just show you some of the
sure.
my.
All right, we'll go over that specifically. Let me.